What if I told you that there are planets out there where the sky rains glass and temperatures soar to unimaginable extremes? Welcome to some of the most perilous, awe-inspiring corners of the universe. Worlds like Proxima Centauri b and TRAPPIST-1e defy our understanding of life and survival. From the depths of a world that absorbs nearly all light to the violent, storm-lashed atmosphere of HD 1897-3b, these planets challenge our very perception of what is possible. Take Proxima Centauri b, for example. This exoplanet orbits the closest star to our solar system, Proxima Centauri. Although it lies within the star's habitable zone, where conditions might, in theory, allow for liquid water, Proxima Centauri b presents terrifying challenges that make any potential human exploration seem nearly impossible. Despite being situated in this so-called Goldilocks zone, the environmental conditions are anything but hospitable. The planet's atmosphere is an enigma. Researchers believe it may be incredibly thin, too weak to support life as we understand it. But it's not just the thin atmosphere that raises alarms. Proxima Centauri is a red dwarf star unlike our Sun. While our Sun is relatively stable, red dwarfs are notorious for their volatility. They emit powerful solar flares and bursts of radiation that could strip away a planet's atmosphere over time, exposing the surface to dangerous levels of radiation. This is not just a theoretical threat. Astronauts visiting Proxima Centauri b would face a significant risk of radiation-related health issues. Prolonged stays on the planet would be hazardous without advanced protective technology. Temperature fluctuations on Proxima Centauri b add to its ominous reputation. The planet is tidally locked, meaning one side always faces its star while the other remains in eternal darkness. This creates extreme temperature contrasts. The daytime side could experience scorching heat, while the nighttime side could plummet to freezing cold. Such drastic differences make it nearly impossible to imagine human survival on the surface, where the potential for life-supporting habitats would be severely limited. Compounding these challenges is the uncertainty surrounding the planet's geological and atmospheric makeup. What if the surface is dominated by active volcanoes, towering mountains, or deep valleys filled with toxic gases? Exploration would not just be dangerous, it could be deadly. Proxima Centauri b's unknowns make it clear that any journey to this distant world would be fraught with peril. Located just over 4 light-years from Earth, Proxima Centauri b offers us a tantalizing glimpse into an alien world. Orbiting a red dwarf star, it lies about 105 million kilometers from Proxima Centauri, comfortably within the star's habitable zone. But proximity to the star brings its own risks. Red dwarfs are known for their intense stellar activity, emitting frequent flares that could potentially bombard the planet with high-energy particles. If Proxima Centauri b's atmosphere is too thin, these flares could strip away any protective layers, making survival even more difficult. Despite its position in the habitable zone, the intense radiation from its parent star could make it incredibly challenging for life, at least as we know it, to survive. Proxima Centauri b is just one example of the many strange and inhospitable worlds scattered across the cosmos. Each of these distant planets holds its own set of terrifying secrets, from toxic atmospheres to blistering heat and catastrophic storms. The universe is full of such alien worlds, each one more enigmatic and dangerous than the last. Red dwarf stars such as Proxima Centauri are some of the most common and fascinating celestial objects in the universe. These stars, though small and relatively cool compared to our Sun, can exert a powerful influence on nearby planets. Proxima Centauri, in particular, is known for its intense magnetic fields which amplify the activity around it. If a planet like Proxima Centauri b, a potentially habitable world orbiting the star, lacks a sufficiently strong magnetic field, it could be vulnerable to harsh solar winds. These solar winds, driven by the star's magnetic energy, could strip away a planet's atmosphere, turning a once promising environment into a radiation-soaked, inhospitable wasteland. Without the protection of a robust magnetic shield, life on such a world could face an environment that is less a sanctuary and more a relentless, unstable radiation zone. However, the fate of Proxima Centauri b may hinge on a different possibility. If the planet has managed to generate its own strong magnetic field, it could deflect much of this harmful radiation. This defense mechanism would help preserve its atmosphere and could lead to a much more stable and favorable environment for life. Understanding the potential habitability of planets like Proxima Centauri b requires studying the complex interplay between a planet's ability to shield itself and its proximity to the life-giving energy of its parent star. This delicate balance could determine whether Proxima Centauri b becomes another barren world in the cosmos or a hidden gem, much like Earth, capable of supporting life. In the search for habitable planets, TRAPPIST-1e stands out as another intriguing candidate. Located within the habitable zone of its ultra-cool red dwarf star, TRAPPIST-1e offers the possibility of liquid water, a key ingredient for life. However, the challenges that lie ahead in making this planet hospitable for human life are considerable. Studies suggest that the atmosphere of TRAPPIST-1e could be thick with gases like carbon dioxide or even ammonia, both of which are toxic to humans. Such an atmosphere would create an inhospitable environment where breathing without advanced life support systems would be impossible. Adding to the complexity is the intense radiation emitted by TRAPPIST-1, its parent star. As an ultra-cool dwarf, TRAPPIST-1 releases significant levels of ultraviolet and X-ray radiation, which could be devastating to any life on TRAPPIST-1e, especially if the planet lacks a magnetic field to shield it. Cosmic rays and harmful radiation could not only pose severe health risks, including heightened cancer rates, but could also strip away vital atmospheric elements necessary for life to thrive. In addition to toxic gases and radiation, the weather on TRAPPIST-1e could prove unpredictable and extreme. If the planet's atmosphere is dense enough, it could trigger violent weather events such as fierce storms or extreme heat waves. These fluctuations in temperature could disrupt the development of sustainable agricultural systems, further hindering any efforts to establish a long-term human presence. Furthermore, constant cloud cover might block sunlight, restricting the growth of plants, which are essential for food and oxygen. The environmental conditions on TRAPPIST-1e illustrate the delicate balance required for any world to support life, not just the right temperature and water, but also a breathable atmosphere, protective magnetic field, and stable weather. For human habitation to be possible, TRAPPIST-1e would require advanced technologies and infrastructure to combat its hostile environment. The possibility of colonizing TRAPPIST-1e, though captivating, also reveals the complexities involved in finding habitable worlds. Its location within the habitable zone suggests it could have water and conditions conducive to life, but the realities of survival on such a world are far from simple. Human exploration or settlement would face formidable challenges, from managing extreme temperatures and high radiation levels to developing technologies that can withstand the planet's hostile atmosphere and weather patterns. Similarly, another fascinating exoplanet, TAR-ES2b, offers an entirely different set of challenges. Located about 40 light-years from Earth, TAR-ES is known for its strikingly dark surface, absorbing nearly 99% of the light that reaches it. Unlike most celestial bodies which reflect light, TAR-ES2b's thick atmosphere, composed of sodium and potassium clouds, creates an almost impenetrable veil, trapping light and contributing to its eerie, perpetual twilight. This extreme darkness not only makes it one of the darkest known planets in the universe, but also raises intriguing questions about its atmospheric composition and the chemical processes that occur there. The profound darkness of TAR-ES2b could also have psychological implications for any human explorers who might visit. In a world where light barely exists, the lack of visibility and constant twilight could lead to disorientation and anxiety. The human psyche, accustomed to a world bathed in light, could struggle with the emotional and mental strain of navigating such a dark and unfamiliar environment. This psychological challenge would be compounded by the isolation of being so far from home on an alien world where even basic concepts like day and night cease to have meaning. Exploring a planet like TAR-ES2b could trigger profound feelings of isolation and unease, as the absence of lights and atmosphere that feels both alien and unnervingly unknown. Each of these worlds, Proxima Centauri b, TRAPPIST-1e, and TAR-ES2b, presents its own set of challenges and mysteries. As scientists continue to probe the depths of space and uncover the conditions of exoplanets, the complexity of finding a truly habitable world becomes ever clearer. It's not just about proximity to a star or the potential for liquid water. It's about understanding the intricate environmental factors that could either support or hinder the development of life. These distant planets may hold the secrets to our future or provide valuable lessons in the search for life beyond Earth, as they reveal the multitude of factors that make a planet capable of sustaining life or making it impossible. The absence of light can be far more than a mere environmental factor. It resonates with profound fears ingrained in human psychology. Darkness has long been a symbol of the unknown, sparking heightened senses of vulnerability and insecurity. On a distant world like Tres 2b, this darkness takes on an even greater significance, amplifying the inherent human fears of isolation and disorientation. For the explorers who venture to this exoplanet, the absence of light wouldn't merely be an atmospheric condition, but a constant psychological challenge. Here, darkness is not just the absence of visible light, but a pervasive force that surrounds them, pushing them to confront the most primal aspects of their humanity. Their senses, already heightened by the sheer alien nature of the environment, would sharpen in response to this oppressive void. Their minds, too, would have to adapt. Tres 2b's explorers are not just battling the physical effects of an inhospitable planet, but also the psychological toll of being light years away from the comforts of Earth. The emotional weight of being so far from home would likely foster a unique bond between the crew members, creating a camaraderie that is born of necessity. In the face of unrelenting darkness, they would rely on one another as their shared source of warmth and light. This deep interdependence could forge relationships that go beyond mere professional connections, as each crew member would be facing the same fundamental challenge: surviving in a hostile, lightless world. The dark side of Tres 2b, with its unyielding cold, might not seem as immediately dangerous as the scorched desert-like terrain of its sun-facing side, but it presents its own set of obstacles. Without sufficient light, the usual methods of harnessing solar energy would be ineffective. For any attempt at colonization to succeed, this problem would need to be overcome by developing innovative energy solutions, possibly relying on advanced technologies like artificial light sources or even nuclear power. Creating sustainable habitats would be another monumental task. Engineers would need to design habitats capable of withstanding the extreme heat on one side of the planet, while ensuring that the cold and dark side doesn't lead to unmanageable drops in temperature. The challenge goes far beyond mere survival. It would test the limits of human innovation and adaptability, requiring explorers to craft new technologies and strategies to thrive in an environment where every day feels like a battle against the relentless forces of nature. At the heart of this struggle lies a deeper philosophical question about the nature of human resilience. How far are we willing to push ourselves to explore the unknown, to colonize new worlds, and to redefine what it means to survive? On a planet like Tres 2b, colonization wouldn't just be a matter of technological capability. It would require a mental fortitude and emotional resilience that could change the very fabric of humanity. And even if technological solutions can mitigate some of the environmental challenges, the psychological toll could be the one obstacle that no human-made technology can fix. Just as humans are constantly pushing the boundaries of space exploration, the extreme environment of Tres 2b stands as a reminder of the colossal challenges that lie ahead in the journey to colonize other worlds. With surface temperatures reaching over 1,000 degrees Fahrenheit and a relentless, unyielding darkness, this planet could offer a future both fascinating and terrifying, a testing ground for humanity's ability to adapt, innovate, and survive. Similarly, Kepler-10b presents another formidable challenge for human life. Located approximately 21 million light-years away from Earth, this exoplanet orbits its star at a dangerously close distance, making it an extreme, hostile environment for any form of life as we know it. The surface temperature of Kepler-10b is so high, surpassing 1,000 degrees Celsius, that the very concept of life in any form becomes impossible. Metals melt in the blistering heat, and the landscape is transformed into an uninhabitable furnace, where the temperature and pressure conditions go far beyond what human biology can endure. Water, a fundamental necessity for life, would not exist in any stable form on this planet. At such high temperatures, any trace of water would immediately vaporize, turning into steam and disappearing into the atmosphere. Without water, the very foundation of life is undermined. The human body itself, which relies on a precise balance of temperature and pressure to function, would be unable to withstand these conditions. The harsh environment of Kepler-10b renders human survival a fantasy, proving that not every exoplanet is a candidate for colonization. In the quest for new worlds, the realities of planets like Kepler-10b challenge the very notion of what is possible in space exploration. While the dream of colonizing new frontiers is exciting, planets like Kepler-10b remind us of the fine line that separates our ambitions from the limitations of our biology. It is one thing to dream of reaching the stars. It is another to face the harsh truth that some worlds are simply too extreme, too inhospitable for human life to thrive. Both TRES-2b and Kepler-10b highlight the need for careful consideration and planning when it comes to the future of human space exploration. They remind us that colonizing new planets is not just a matter of technological advancement. It is a test of human ingenuity, resilience, and adaptability in the face of overwhelming odds. The challenges these planets present are not just scientific or engineering problems. They are profound psychological and philosophical questions that will shape the future of humanity's exploration of the cosmos. The atmospheric conditions on Kepler-10b present formidable challenges for any potential life forms, especially for humans. Its proximity to its star results in a powerful gravitational pull and intense radiation, making it nearly impossible for the planet to maintain a protective atmosphere. The absence of breathable air, rich in oxygen, further diminishes the possibility of human survival. Instead, Kepler-10b's atmosphere is more likely composed of hazardous gases, posing serious risks to any living organisms attempting to survive there. The planet's extreme environment is also marked by lethal temperatures and the lack of liquid water, adding to the hostile nature of the atmosphere. These conditions are a stark reminder of the delicate balance that allows life to thrive on Earth. In contrast, Kepler-10b serves as a harsh example of the inhospitable realities that await human exploration beyond our own planet. Human missions to other planets are heavily reliant on the composition of their surfaces and the gravitational forces at play. Each planet's geological structure is unique, which can impact both surface conditions and the operation of landing crafts. For example, some planetary surfaces are dominated by fine dust that creates significant challenges for mobility. Rovers and landers may become bogged down, unable to gain traction, or simply struggle to move. Other planets might be littered with jagged rocks or boulders, which pose even greater risks to exploratory vehicles attempting to navigate the terrain. The gravitational forces that govern a planet's environment are another crucial factor. Planets with weaker gravity, such as Mars, present unique landing challenges. Although weaker gravity might seem advantageous, it complicates the landing process, as spacecraft struggle to gauge their descent speed accurately. With less gravitational force, it becomes more difficult to control the landing trajectory, and there is a higher risk of bouncing upon impact. On the other hand, planets with stronger gravitational fields, such as Jupiter, present a much more formidable challenge. Any landing attempt on such a planet would require enormous energy and the use of highly robust designs to withstand the immense forces at play during descent. The challenges multiply as the spacecraft must endure increased atmospheric pressure and gravitational pull, making landings on these giants incredibly complex and resource-intensive. Moreover, the chemical composition of a planet's rocks can introduce new risks for human exploration. Certain minerals, when disturbed, can release toxic elements, posing a direct health hazard to astronauts. Additionally, the interaction between the planet's rocky surface and the technology humans use could lead to unforeseen reactions that may cause malfunctions or damage essential equipment. Geologically unstable planets add another layer of unpredictability, with volcanic eruptions, landslides, or seismic activity posing significant threats to any ongoing missions. Understanding these geological characteristics, such as the chemical composition of a planet's surface and the gravitational forces at play, is crucial for ensuring the safety and success of future exploration efforts. Only by comprehensively studying these factors can we hope to navigate other worlds effectively and unlock the potential for discovery within our solar system and beyond. Turning our gaze to HD 9733b, a planet located roughly 60 light-years away from Earth, we encounter an even more extreme environment. This exoplanet is a stark example of the violent and unpredictable weather systems that can exist in other corners of the universe. The most extraordinary feature of HD 9733b is the ferocity of its storms. Winds on this planet can reach speeds of up to 2,000 miles per hour, more than 800 times faster than the strongest winds recorded during a hurricane on Earth. These wind speeds, combined with the planet's intense atmospheric conditions, make it a truly hostile environment for any potential exploration. The sky on HD 9733b is not only filled with these incredibly strong winds, but also experiences an unusual form of precipitation, glass rain. The planet's unique combination of temperature and atmospheric pressure causes silicate materials to condense and fall as sharp glass-like shards. These lethal raindrops travel at extraordinary speeds, turning any downpour into a deadly hazard. Imagine standing in a storm where the very rain itself could slice through the air with deadly precision. Temperature fluctuations on HD 9733b are another significant factor contributing to its hostile environment. The day side of the planet reaches scorching temperatures of around 2,000 degrees Fahrenheit, while the night side plummets to much lower levels. This extreme contrast creates intense thermal currents in the atmosphere, driving unpredictable weather patterns. The interaction between the hot and cold regions leads to the formation of chaotic storms, creating a tumultuous and dangerous atmosphere that is constantly shifting and evolving. Iron clouds and molten glass also form in the skies of HD 9733b, contributing to the bizarre and deadly nature of the planet's weather. These high-pressure systems, coupled with extreme heat, generate colossal storms that are unlike anything humanity has ever encountered. The sheer magnitude of these storms, both in scale and intensity, makes the planet a daunting prospect for any future exploration. HD 9733b is a glaring reminder of the incredible diversity of planetary environments that exist in the universe. While Earth's conditions are finely tuned to support life, planets like HD 1897333b demonstrate just how inhospitable the cosmos can be. The extreme weather and violent storms on this exoplanet provide an alarming glimpse into the challenges that await future human visitors, should we ever attempt to reach such worlds. Closer to home, gas giants like Jupiter and Saturn offer their own set of extreme conditions. These planets are known for their fierce, long-lasting storms, some of which have persisted for centuries. The winds on these gas giants can reach speeds of several hundred miles per hour, posing a serious risk to spacecraft attempting to navigate or orbit these planets. These powerful winds, combined with intense atmospheric pressures, could easily damage or destroy any craft exposed to them. Temperature variations within the atmospheres of gas giants also present significant challenges. Depending on the depth within their atmospheres, temperatures can vary dramatically, ranging from searing heat to bone-chilling cold. For any human mission to these planets, specialized technology would be necessary to protect against the intense temperature fluctuations and crushing pressures. The complexity of such missions would be immense, requiring robust spacecraft and life support systems capable of withstanding these harsh conditions. As we look toward the future of space exploration, the lessons from planets like Kepler-10b, HD 1897333b, and the gas giants serve as crucial reminders of the obstacles humanity must overcome to reach other worlds. From extreme weather to geological hazards, the challenges are vast and varied. Only through careful preparation, cutting-edge technology, and a deep understanding of these distant environments can we hope to safely explore these worlds and one day unlock their secrets. Exploring other worlds has always been a captivating pursuit for humanity. Yet as we begin to probe deeper into the mysteries of distant planets, we must confront not only the allure of discovery, but also the harsh, unyielding realities of extreme environments that pose significant risks to human life. The composition of planetary atmospheres, for instance, often includes toxic gases like ammonia and methane, creating hazardous conditions for any potential explorers. Such planets may be surrounded by thick clouds of these gases, which could be deadly to humans without the aid of advanced life support systems. To navigate such toxic atmospheres, a spacecraft would require cutting-edge technology capable of filtering and providing breathable air while shielding the crew from these harmful substances. But the challenge extends far beyond just managing the air we breathe. Any crew venturing to these planets would also need to contend with violent storms, harsh temperature fluctuations, and corrosive elements in the environment. These conditions demand habitats that can withstand these violent forces while ensuring a safe and habitable environment for the crew. The thrilling prospect of space exploration is tempered by the realization that the very environments we wish to explore may be as deadly as they are fascinating. As humanity looks toward the stars, understanding the extreme conditions of distant planets will be key to developing the safeguards necessary to keep astronauts alive and well. Consider WASP-121b, an exoplanet located about 800 light-years away in the constellation Puppis. This gas giant is not just another distant world, it is a true outlier in planetary science, a prime example of what makes some planets so inhospitable. Orbiting incredibly close to its star, WASP-121b experiences temperatures that can soar to more than 1,500 degrees Celsius. At these temperatures, elements like metals, which are typically solid on Earth, exist in a molten state. This extreme heat creates an atmosphere unlike anything we've encountered, filled with metallic vapors that are both toxic and corrosive. Any human attempt to explore this world would require a massive technological feat just to survive. The presence of molten metals, such as iron, in the atmosphere of WASP-121b adds a further layer of danger. As these metals vaporize, they contribute to the creation of a thick, toxic atmosphere that would be lethal to humans. Even the most advanced protective suits would struggle to hold up against the bombardment of molten droplets raining down from the planet's blistering atmosphere. The constant assault from these substances could cause catastrophic failure in equipment, rendering any mission on this planet almost impossible. Furthermore, the extreme temperature differences on either side of the planet add another layer of risk. One side of the planet is constantly exposed to the unrelenting heat of its star, while the other side remains much cooler. This disparity would create the danger of thermal shock, which could damage life support systems, critical equipment, and the integrity of any habitat placed on the surface. Along with the intense heat, the radiation from the nearby star would further complicate any attempts at human exploration. The radiation levels on WASP-121b would be far beyond what we experience on Earth, and the presence of molten metals would only amplify the risks. The combined effects of extreme temperatures, toxic vapors, and high radiation levels create an environment so harsh that the idea of human exploration seems almost unimaginable. As much as the planet ignites curiosity about the outer limits of the universe, it also serves as a poignant reminder of the monumental challenges we face in reaching out beyond our home planet. Even in the pursuit of scientific discovery, we must be mindful of the risks involved. While WASP-121b represents one of the most extreme planets known to humanity, it also underscores the importance of careful planning and technological innovation in the quest for interstellar exploration. The psychological toll of exploring such a world would also be immense. The sight of temperatures soaring well above 1,700 degrees Fahrenheit, combined with the relentless assault of molten metals and toxic vapors, could evoke a profound sense of isolation and vulnerability in any astronaut exposed to these conditions. In the face of such an inhospitable environment, the crew might experience overwhelming fear, realizing just how fragile human existence is in the vast, indifferent universe. The loneliness of space travel, already a known psychological challenge, could become even more acute when faced with the intense, unyielding hostility of another world. The constant bombardment from the planet's extreme conditions could heighten feelings of helplessness, as astronauts would be forced to confront forces beyond their control. But beyond the fear and anxiety that might arise, there could also be a profound sense of awe. Witnessing the harsh realities of a world like WASP-121b might inspire reflections on the resilience of life on Earth. The contrast between our planet's rich, life-sustaining environment and the violent, hostile features of this distant world could lead to a deeper appreciation for the uniqueness of our own existence. Such a realization might spark philosophical discussions among crew members about the fragility of civilization, the survival of life, and the existential nature of humanity in the cosmos. At the same time, these reflections could also give rise to feelings of insignificance, as the vastness of the universe places humanity's achievements into stark perspective. In the end, the exploration of planets like WASP-121b may drive home just how much we have yet to learn about space, and how far we still have to go before we can truly call the stars our home. These worlds, with their extreme environments and impossible conditions, will continue to capture our imaginations, but they also highlight the immense challenges humanity faces as we seek to transcend the confines of our home planet. In our drive to explore, we must remain ever aware of the brutal realities that await us on the far edges of the universe, and the strength and resilience required to face them. The psychological effects of space exploration can vary drastically from one individual to the next, shaped by personal experiences and unique coping mechanisms. For some astronauts, the quest for knowledge and discovery can serve as a profound source of motivation, a driving force that pushes them to explore the unknown. However, for others, the overwhelming challenges of space travel, both physical and mental, can lead to feelings of anxiety, stress, and isolation. This stark variability emphasizes the importance of mental preparation and robust support systems for astronauts about to embark on exploratory missions. As humanity continues to push the boundaries of space exploration, understanding these psychological implications becomes vital. Ensuring astronauts are equipped to face the unknown, both physically and emotionally, is essential to the success of future missions. Take, for instance, the exoplanet 55 Cancri e, an intriguing and extreme world located light years away. Known for its volatile volcanic surface, this planet presents an extraordinary yet perilous environment. Vast lava fields and rivers of molten rock stretch across its surface, and any human encounter with such a landscape would almost certainly encounter severe hazards. One of the most striking features of 55 Cancri A is the intense heat produced by its relentless volcanic activity. Temperatures soar to extreme levels, placing it among the hottest planets discovered to date. A human attempt to explore this world would face immediate dangers due to the overwhelming heat, but the physical heat is only one of the challenges this planet presents. The atmosphere of 55 Cancri A is thought to be thick with exotic materials, vaporized rock, and various gases expelled from its frequent volcanic eruptions. This thick, toxic atmosphere could make the very act of breathing a perilous task. Even if futuristic technologies could create protective gear capable of withstanding the intense heat, the presence of hazardous gases would require intricate filtration systems that may not yet exist or be fully functional. Furthermore, the unpredictable nature of volcanic eruptions adds another layer of risk. With seismic activity potentially altering the landscape in seconds, navigating this tumultuous environment would be an enormous challenge. Structures and equipment sent to the planet would need to withstand not only extreme temperatures, but also the shock waves from nearby eruptions, which could destabilize habitats or disrupt critical scientific investigations. The prospect of studying 55 Cancri AA remains undeniably captivating, but the planet's volatile nature brings to light the dangers that could confront human explorers. Each exploration of distant worlds offers valuable insights into the inhospitable environments that could meet humanity, offering a reminder of the immense barriers we must overcome in our quest to explore the cosmos. The very real risks of seismic events on such planets could also have serious implications for space missions. Earth itself offers a parallel to these risks, particularly in regions with high seismic activity, such as California or Japan. Here, tectonic plate movements lead to unpredictable geological phenomena, including earthquakes and volcanic eruptions. These natural events can pose severe threats to both crewed and uncrewed spacecraft, as ground shaking, landslides, or volcanic ash clouds could disrupt essential operations such as launch and landing. Mission planners are keenly aware of the risks posed by seismic activity. In regions known for their geological volatility, like the Pacific Ring of Fire, thorough preparation is key. Engineers and mission planners craft intricate strategies to ensure that exploration missions are as safe as possible. This involves determining safe zones for research bases and designing spacecraft to endure unexpected seismic events. Even the most carefully crafted spacecraft are built with the assumption that unpredictable geological forces could strike at any moment. Such designs are crucial to ensuring the integrity of missions, safeguarding both the equipment and the astronauts on board. In addition to resilient design, the use of seismic monitoring systems plays a pivotal role in enhancing safety. These systems continuously track ground movements, providing early warning signals of any impending seismic events. In the event of such an occurrence, precautionary measures can be enacted, such as relocating personnel or securing sensitive equipment, to mitigate the risks posed by these unpredictable natural forces. The ability to respond effectively to these threats is essential not only for the safety of the mission, but also for the advancement of scientific understanding. Exploration in seismically active regions offers a unique opportunity to study the forces that shape our planet, but it must be approached with caution and meticulous planning. The allure of exploring places with significant geological activity is tempered by the immense risks involved. While such missions can lead to groundbreaking discoveries, the threat of seismic instability cannot be ignored. The balance between the potential for discovery and the risk to human life is delicate. Yet, the ability to adapt to these challenges, to develop the technologies and strategies necessary to withstand seismic events, will deepen our understanding of both the cosmos and the planet beneath our feet. In the case of exoplanet 55 Cancri E, another fascinating yet perilous aspect of the planet lies in the realm of time itself. The planet's unique orbit and gravitational influences lead to extreme time dilation, a phenomenon that occurs when an object moves at a significant fraction of the speed of light or is subjected to intense gravitational fields. As 55 Cancri A orbits its host star, it experiences time in a way that is radically different from our own perception. For astronauts visiting the planet, this could result in profound psychological consequences. Time dilation means that, while only a few months might pass for those on the planet, years could pass on Earth. This discrepancy could create a significant psychological disconnect, as travelers might find themselves isolated from the world they left behind. This difference in the passage of time can lead to feelings of alienation and anxiety. Relationships with loved ones could change irreparably during their extended absence. The psychological burden of returning to a world that has moved on without them could be overwhelming, leading to feelings of displacement and uncertainty. Such an experience would not only challenge the astronaut's sense of self, but could also profoundly alter their perception of time and their connection to Earth. The mental strain of navigating such a unique phenomenon of time could be just as daunting as the physical challenges posed by the planet itself. As humanity continues its exploration of distant worlds, understanding the complex interplay between the physical and psychological effects of space travel becomes crucial. The journey to other planets and exoplanets is not just a scientific endeavor, but one that calls for profound human resilience and adaptability. The uncharted territories of time and space may offer us the promise of discovery, but they also present dangers that are as complex and unpredictable as the planets themselves. Time, in its simplest form, is a linear progression we take for granted. Yet, for those venturing beyond our earthly bounds, time can become a perplexing force, transforming the very essence of their experiences. In the vast stretches of space where distances and the bending of time collide, the act of traveling through time, whether forward or backward, becomes a journey of identity, perception, and profound psychological transformation. Imagine stepping into a spacecraft, embarking on a voyage to distant stars, and feeling the sensation of time itself morphing into something unrecognizable. The rhythms of Earth seem a distant echo, the environment around you ever-changing as distant stars and planets spin in their eternal dance. As you travel, your perception of reality can warp. The world you left behind, your home, your loved ones, seems to shift, changing in ways unimaginable. What was once familiar becomes alien. The passing of time on Earth continues, but for you it might feel as if it has stretched into infinity or contracted into an instant. This altered sense of time challenges the very foundation of what it means to be human. How do you reconcile the person you were when you left with the person you are becoming in this new, distorted reality? The mental toll can be significant. Questions about your identity and purpose arise. Who are you in a universe where everything you once knew has changed? The awareness that life on Earth is continuing without you can provoke an unsettling sense of insignificance. There is a quiet, melancholic realization that the world does not pause for one individual's absence, and that can be a heavy burden to bear. When such travelers finally return home, the experience of reintegration into society can be jarring. The world they return to has evolved in ways they might never have imagined. It is as though they have been out of sync with time itself, and now even their familiar surroundings feel out of place. The emotional dissonance is stark. The connection to the present moment feels tenuous, strained by the years or decades spent away from it. Yet, these visitors may also find that time itself behaved differently while they were away. In the distant planets where they explored, time did not pass as it did on Earth. The flow of moments, some fleeting, others seeming to stretch endlessly, created a cognitive dissonance within them. The duration of their experiences no longer aligns with the time they once knew. A day on Earth might have been the equivalent of hours or millennia in the vastness of space. When such discrepancies arise, it is not just the passage of time that feels fractured, but the very fabric of their perception. This is where the psychological support for space explorers becomes paramount. The physical demands of space travel are immense, but the emotional and mental toll is perhaps even more formidable. In the face of time dilation and the isolation of deep space, astronauts must possess not only physical resilience, but also an unparalleled psychological fortitude to cope with the disorienting effects of their journey. The mental strain they face must be met with structured, robust support to ensure they can navigate not just the stars, but their own shifting identities and perceptions. As humanity extends its reach to the farthest corners of the universe, we encounter not just the possibility of time manipulation, but also the daunting prospect of surviving in environments that challenge the very essence of human endurance. One of the most extreme scenarios involves the discovery of lava oceans on celestial bodies, such as the moons of Jupiter and Saturn. These molten seas, with temperatures soaring to thousands of degrees, pose unimaginable challenges for human survival. The equipment that has served us in past space missions would be woefully inadequate for such an environment. The materials that have been our foundation for space exploration, resilient yet fragile in the face of extreme conditions, would falter against the searing heat and the corrosive nature of molten rock. What is required are high-performance materials, designed to withstand not just the intense heat, but also the abrasive, ever-shifting nature of lava itself. But the challenge doesn't end with the materials. The design of equipment must undergo a radical transformation. Tools and life support systems, which rely on the stable conditions of Earth's atmosphere, would break down in such an environment. Every system, from the smallest component to the largest vehicle, must be reimagined to survive. Heat-resistant thermal barriers, robust seals to prevent catastrophic failure, and advanced safety protocols will be essential. The risks of sudden eruptions or unexpected shifts in the molten landscape require constant vigilance and advanced monitoring systems to ensure the safety of any explorers. Beyond the equipment, mobility on such volatile terrain is a critical challenge. The fluidity of lava oceans presents unique obstacles. How do you navigate or build habitats on surfaces that are in constant motion? Every step taken in this hostile environment would require precision and an innovative approach to movement. Whether it's designing exploration suits that can withstand the intense heat, or vehicles capable of gliding across or even submerging into lava, engineers and scientists would be forced to think beyond the conventional. This type of exploration would require not just physical endurance, but mental adaptability. The environmental factors, heat, unpredictable eruptions, toxic gases, would weigh heavily on the mind. The knowledge that these hazards are lurking beneath the surface would create a persistent undercurrent of anxiety. Still, it is through these challenges that humanity's technological prowess and resilience would be tested, pushing the limits of what we are capable of. As we venture into these extreme environments, we are reminded of the ingenuity required to survive on worlds so vastly different from our own. The potential to encounter lava oceans on distant moons forces us to rethink the possibilities of human space exploration, and whether we are ready to adapt to a cosmos that can be as beautiful as it is brutal. In our search for habitable planets beyond our own solar system, one of the most intriguing objects in the sky is an exoplanet known as Glia 436b. Located about 32 light years from Earth, this planet challenges everything we think we know about planetary systems. A hot Neptune, it combines icy and rocky elements with a thick, dense atmosphere. What makes Glia 436b so captivating and perplexing, however, is its extreme combination of high temperatures and intense atmospheric pressure, creating conditions that are utterly alien to us. Perhaps the most astonishing feature of Glia 436b is its water, if it can be called that at all. The pressure on this planet is so immense that water exists in a vapor state, far denser than anything we could recognize as liquid water. The resulting environment is thick with mist, giving the planet an eerie, smoky quality. In this strange and dense atmosphere, water can even form exotic states of matter, such as superpionic water. This phenomenon occurs when oxygen molecules become trapped in crystalline structures, and hydrogen ions flow freely between them, an occurrence that disrupts our understanding of how matter behaves under extreme pressure. For scientists, these observations are both exciting and alarming. If such strange forms of water exist, what else about this planet defies explanation? The intense pressure might also mean that the planet's gravitational pull is stronger than Earth's, approximately 1.5 times as strong. This would have significant implications for both the planet's atmosphere and any surface conditions. How would such an atmosphere behave under this gravitational force? Could high-speed winds contribute to an unstable, unpredictable weather pattern, altering the very composition of the atmosphere itself? The mysteries surrounding Glia 436b are many, and with each new discovery, the challenges of understanding planets beyond our own solar system become even more complex. The planet's extreme density compounds the difficulty of exploring its surface. On a body like Jupiter, known for its massive density, the atmosphere's weight would be overwhelming. The sheer pressure would affect every aspect of exploration, from the equipment used to the very bodies of those attempting to walk on its surface. The experience of moving on such a planet would feel completely foreign. The stronger gravitational pull would place enormous strain on explorers' bodies, leading to discomfort, fatigue, and perhaps even serious health issues. The very act of moving would become an endurance test. Muscles and bones would strain against a force they were never meant to endure. In this dense environment, it would not just be the physical strain of gravity, but also the chemical dangers. For example, thick clouds composed of ammonia and methane would pose a constant threat, and the planet's low visibility would only heighten the sense of isolation and fear. Explorers would face the unnerving reality of navigating through hazardous terrain and an atmosphere that feels alien in every sense. Compounding the physical and environmental dangers is the psychological toll such an extreme world would take. The sensory overload caused by unfamiliar sounds, pressures, and potentially violent weather phenomena would contribute to an ever-present sense of disorientation. Each step, each movement would feel like a struggle against forces that constantly remind explorers of their vulnerability. The emotional and mental resilience required to endure such conditions would be immense. It is a stark reminder of the complexities of planetary exploration in environments far beyond our earthly experiences. On another exoplanet, LHS 3844b, the absence of a significant atmosphere presents unique challenges. Without an atmospheric shield, explorers would be exposed to the harsh realities of space. Cosmic radiation and solar winds would reach them without any protective barrier. This lack of atmosphere could cause irreparable damage to equipment and pose grave risks to human health. The radiation could easily penetrate habitats and spacesuits, making the exploration of such a world not only a physical challenge, but a fight for survival against the fundamental elements of the cosmos itself. As we continue to push the boundaries of space exploration, we encounter not only the wonders of the universe, but the countless hazards that come with it. Each new world presents a unique challenge to humanity, testing our ingenuity, resilience, and adaptability. The journey ahead promises to be one of constant discovery as we venture further into the cosmos than ever before. The lack of atmospheric pressure on distant exoplanets creates a unique set of challenges that limit the potential for life and the feasibility of exploration. In environments like these, if surface water exists, it would either evaporate or freeze, depending on the temperature. These extremes make the planet a hostile and inhospitable place where the likelihood of life as we know it is significantly reduced. For any kind of exploratory mission, the instruments designed for this purpose must be uniquely constructed to endure these severe conditions, including dramatic temperature fluctuations and the absence of thermal insulation. Such conditions make missions more complex and costly. Another significant issue is landing on and navigating a planet's surface when there's no atmosphere to provide aerodynamic drag or resistance. On Earth, spacecraft can rely on parachutes or atmospheric friction to slow down during landing, but these methods would be entirely ineffective in an atmosphere-less environment. Without these crucial tools, a spacecraft might slam into the surface at high velocity, which presents the risk of catastrophic damage or destruction. This necessitates the development of entirely new landing technologies that are capable of slowing descent and ensuring a safe touchdown, possibly through innovative propulsion or other unconventional techniques. The elements of a planet like LHS 3844b not only present immense technological challenges, but also demand extensive planning and preparation. Understanding these factors is essential for any future missions that aim to explore such distant, extreme worlds. These considerations aren't just technical hurdles, but existential ones, raising questions about the limits of human innovation and survival. To truly unveil the mysteries of these far-off places, scientists must confront these hazards head-on, adjusting their strategies to the harsh realities of extraterrestrial environments. LHS 3844b itself is an extraordinary exoplanet located roughly 250 light-years from Earth. This rocky world is marked by extreme temperature fluctuations that make it an anomaly in our study of habitable worlds. During the day, the temperature can rise to over 1,000 degrees Celsius, making it one of the hottest known exoplanets. At night, however, the temperatures can drop drastically to near absolute zero. These extreme shifts in temperature, often oscillating from blistering heat to numbing cold, are completely unlike anything seen on Earth and would make survival in these conditions near impossible without advanced technologies. Human beings are finely tuned to thrive within a relatively narrow range of temperatures, and the drastic swings on LHS 3844b would present an enormous challenge for any future settlers or explorers. The design of habitats on such a planet would require not only revolutionary technology, but also an entirely new way of thinking about human habitation in alien environments. To survive on this planet, shelters would need to be self-regulating and highly insulated, capable of maintaining a stable internal environment amidst the chaos of fluctuating external temperatures. This would be akin to creating isolated environments within a hostile world, where each habitat would serve as a small sanctuary of stability. In addition to the technical hurdles, the psychological toll of living on such a planet cannot be ignored. The vast differences in temperature between day and night could leave inhabitants disoriented and disconnected from the familiar rhythms of life on Earth. The isolation, compounded by the relentless extremes of this alien world, could have profound mental health consequences. Moreover, the constant exposure to solar radiation during the day could further complicate the survival equation, even for technologically advanced life support systems. These systems would have to continuously adapt and adjust to ensure the well-being of their inhabitants, adding another layer of complexity to the mission. Living on LHS 3844b would require more than just advanced technology. It would demand a complete rethinking of how we perceive survival and adaptation in the universe. It would challenge our very understanding of what it means to be human in an alien environment. While humanity's capacity for innovation is vast, this radical new frontier would force us to confront the fundamental fragility of life as we know it. Our pursuit of exploring and adapting to such worlds raises profound philosophical questions about human resilience, adaptation, and our place in the cosmos. Kepler-13b, another exoplanet in the constellation Cygnus, offers a similarly awe-inspiring yet terrifying view of what may await us in the vastness of space. As scientists study the data gathered from this distant world, they uncover a planet marked by massive, violent storms and turbulent cloud formations that cover its surface. The atmosphere of Kepler-13b is marked by extreme temperatures, often surpassing 2,000 degrees Fahrenheit, and its weather systems are far more severe than anything experienced on Earth. The storms on this planet are not only fierce, but also of such scale that they dwarf even the most intense weather patterns our planet can produce. The swirling clouds on Kepler-13b are composed largely of vaporized minerals, creating an environment that is both volatile and mysterious. The sheer intensity of the weather suggests that there is much we still do not understand about what lies beneath the surface. These chaotic conditions pose significant challenges for any attempt to explore the planet, particularly in the development of spacecraft capable of withstanding both the extreme pressure and intense heat. The fierce winds, which can reach speeds near the sound barrier, further complicate the task, raising concerns about the durability of spacecraft in such an environment. The storms on Kepler-13b are not merely dramatic, they are unpredictable, threatening the safety and viability of any exploratory mission. The scale and violence of these storms suggest that even the most advanced technologies may be inadequate for tackling this world's many hazards. To explore a planet like Kepler-13b would require groundbreaking advancements in engineering, crafting new technologies capable of enduring the relentless atmospheric pressure, extreme heat, and violent storms. It's a world that reminds us of the unpredictability and chaos that can exist in the universe, an environment so extreme that even our most ambitious designs could be tested to their limits. Kepler-13b, like many other exoplanets, challenges our assumptions about what it takes to survive and thrive in the harshest of environments. Whether through innovation or sheer willpower, the exploration of such worlds will require humanity to adapt in ways we have yet to imagine. This planet is a stark reminder of the complexities that await us as we venture beyond the familiar confines of our solar system into the vast unknown of space. The very atmosphere of distant worlds can evoke a sense of unease, amplifying the stark challenges humanity would face in exploring them. In the case of Kepler-13b, the very air seems to shimmer with menace. The planet's skies are streaked with metallic clouds formed from minerals like iron and titanium, hinting at storms that rage not only with ferocity, but also with a corrosive bite. These turbulent weather patterns suggest a hostile environment, where the forces of nature could wage war on any technology attempting to unlock the planet's secrets. The relentless aggression of Kepler-13b's storms would no doubt result in a violent clash between the planet's environment and the machinery designed to study it. Such an interaction presents an unsettling prospect for future human exploration, highlighting the risks that lie beyond our current capabilities. As scientists look toward the possibility of future missions to this distant world, they are forced to reflect on lessons learned from our own planet's extreme weather events. The combination of intense heat, constant storms, and corrosive compounds creates a harsh reality for any explorers daring enough to venture there. It is a sobering reminder of how fragile our human attempts to conquer the unknown truly are, pushing us to consider the limitations of our technology and our bodies. Kepler-13b challenges us not only with its extremes, but also with the realization that humanity's quest for knowledge comes at a profound cost. The pursuit of understanding these far-off worlds forces us to contemplate the inherent risks of space exploration and how they might shape the future of our endeavors. Kepler-13b itself is an extraordinary example of the diversity that exists in the cosmos. This exoplanet orbits its star at a disturbingly close distance, subjecting it to gravitational forces more than twice as strong as Earth's. The implications of this intense gravity on human physiology are staggering. Our bodies, shaped and adapted to Earth's gravity, would struggle under such overwhelming forces. At the International Space Station, astronauts experience muscle atrophy and bone density loss due to the lower gravity, but on Kepler-13b, the situation would be far more severe. The human frame designed to withstand Earth's gravity would face unimaginable strain. Muscles and bones under such pressure might not be able to handle the immense weight, resulting in fatigue and even stress fractures. The cardiovascular system would not be spared. The heart, which works tirelessly to pump blood throughout our bodies, would face additional strain. In a high-gravity environment, the heart would have to work harder to circulate blood against the stronger gravitational pull, which could lead to elevated blood pressure and an increased risk of cardiovascular issues over time. For humanity to survive in such a harsh environment, revolutionary advances in medical science and human adaptation would be required. It is a testament to human resilience, though, that we would likely attempt such an extraordinary feat, pushing the boundaries of science to allow us to endure what nature had never intended for our bodies. The dangers do not stop there, however. GJ3470b, another exoplanet located approximately 21 light-years away in the constellation Capricornus, presents its own set of challenges. Known for emitting high-energy radiation, including X-rays and gamma rays, the planet raises critical questions about the safety of human exploration. On Earth, our atmosphere shields us from harmful radiation, but GJ3470b's proximity to its red dwarf star means the planet faces extreme radiation exposure. If there were any chance of life on this planet, it would likely require thick protective atmospheres or magnetic fields to deflect the radiation that bathes it. Even without the prospect of life, however, the radiation presents an enormous challenge to human exploration. The high-energy emissions from GJ3470b not only pose a direct threat to any missions sent to the planet, but also to its atmosphere. Such radiation can strip away particles from the atmosphere, making it increasingly difficult to sustain an environment where life could potentially thrive. If we were to consider colonizing such a planet, we would need to account for this radiation and develop advanced technologies to shield both our people and the equipment sent to study the world. These emissions highlight a sobering reality. The universe is not only fascinating but perilous, with each new discovery presenting as many dangers as it does possibilities. Temperature extremes are another challenge faced by many planets orbiting too close to their stars. The proximity of these worlds to their suns results in extreme, prolonged exposure to stellar radiation, creating surfaces so hot that they might actually melt. The surface conditions of such a planet would render any exploration effort not just difficult, but outright impossible. Even if the planet's surface could somehow withstand the heat, the atmosphere would be subject to violent and unpredictable weather patterns. Gases in the atmosphere might become superheated, triggering fierce storms and thermal fluctuations that could drastically alter the conditions from one moment to the next. Any human mission to such a world would need to be equipped with extraordinary technology capable of surviving this relentless barrage of heat, while also ensuring the safety of those involved. In the vastness of space, planets like Kepler-13b, GJ3470b, and others serve as stark reminders of the challenges humanity would face as we attempt to venture beyond the familiar confines of Earth. These worlds, with their extreme environments and hostile conditions, stand as both a test of our technological ingenuity and a reflection of our capacity for endurance. The questions they raise about the limits of human exploration are profound, pushing us to consider not only what we might learn, but also the cost of that knowledge. As we continue to reach for the stars, we must remain mindful of the dangers that lie in wait, acknowledging both the awe and the peril that come with exploring the unknown. Temperature fluctuations on distant planets present some of the most significant challenges for space exploration, especially when it comes to technological resilience. Instruments designed for planetary exploration are typically built to function within specific temperature ranges. But what happens when these ranges are exceeded? In the case of extreme heat waves, these technologies could fail or lose effectiveness, causing catastrophic damage to scientific missions. The consequences are stark. Prolonged exposure to such heat can warp materials, disrupt electronics, and degrade the structural integrity of equipment. On these extreme worlds, engineers and scientists must develop innovative, high-tech solutions capable of enduring the harshest conditions imaginable. It's not just about building more durable tools, it's about entirely rethinking the technology we use to explore space, which inevitably drives up both complexity and cost. The threats posed by extreme heat waves, especially those generated by close orbits around their stars, require cutting-edge solutions to ensure mission success and the safety of the equipment, all while uncovering the mysteries of these hostile environments. The quest for knowledge never halts, even when faced with seemingly insurmountable obstacles. Kelt 9b, an exoplanet located roughly 175 light-years away in the constellation Cygnus, stands as a perfect example of such extreme conditions. Often described as an astronomical enigma, Kelt 9b is the hottest known exoplanet in existence. It orbits its star at breakneck speeds, and its surface temperature soars to an astonishing 4,300 degrees Celsius, far hotter than molten lava. This scorching environment poses unique opportunities for scientific exploration, forcing astronomers to rethink what is possible when it comes to studying planetary atmospheres. The planet's extreme heat causes its atmosphere to behave in ways unlike anything we've observed in our own solar system. Sodium and potassium, for instance, may exist as gases in the upper atmosphere, creating a dynamic and volatile chemical environment. This gives scientists the rare opportunity to study these elements in a setting completely different from anything found on Earth. Could new forms of weather emerge in such an atmosphere? Could chemical reactions occur, fueled by the intense energy from the star? These are some of the intriguing questions that Kelt 9b raises. As Kelt 9b orbits its parent star, the tremendous radiation it receives only intensifies its atmospheric complexity. The light and energy from the star trigger various photonic interactions, which could lead to unpredictable phenomena in the planet's atmosphere. Cloud formations, chemical reactions, and even weather patterns might emerge in ways that defy our current understanding. This unprecedented level of exploration not only challenges current astronomical models, but could also open new doors in our comprehension of planetary systems. Kelt 9b forces scientists to reevaluate the very fundamentals of planetary formation. Its extreme conditions suggest that planets may evolve in ways we had never before considered, adding a layer of unpredictability to our understanding of exoplanetary environments. It serves as a fascinating reminder of the diversity of planets in our universe, continually inviting both awe and further investigation. However, studying planets like Kelt 9b brings its own set of difficulties. The extreme conditions found on planets such as Venus, with surface temperatures hot enough to melt lead, serve as a vivid reminder of the risks involved in such missions. Any spacecraft sent to study these worlds must be built with materials capable of withstanding punishing heat and corrosive atmospheres. These conditions can wear down even the most advanced equipment, leading to rapid degradation or complete failure. Even before reaching the planet's surface, probes may face the risk of damage from the very gases and acids in the atmosphere. Moreover, the potential for unpredictable weather patterns complicates the equation further. Jupiter, for example, is home to violent massive storms, including colossal cyclones. Should a probe enter the path of one of these storms, it could be subjected to winds and atmospheric turbulence far beyond its design limits. The danger doesn't stop with equipment failure. It also threatens the safety of human missions. If humanity ever hopes to send astronauts to explore or settle on planets with such extreme conditions, advanced shielding against the heat, toxic gases, and pressure would be essential. Only with the right technology could we even begin to entertain the idea of human exploration in these hostile environments. The quest to explore extreme exoplanets is fraught with peril, but the discoveries to be made are profound. The knowledge we gain from these distant worlds could reshape our understanding of the universe. Yet, as we look to the stars, we are reminded of the staggering complexity and danger of exploring planets that push the very limits of what is possible. Among the many fascinating worlds we've discovered, HAT P7b stands out as another exoplanet that tests the boundaries of our understanding. Located around 1,000 light-years away in the constellation Cygnus, HAT P7b is a gas giant that orbits its parent star so closely that its surface temperatures reach unthinkable extremes. These extreme temperatures not only generate scorching heat, but also create violent weather systems, including enormous storms that could blanket the planet. On HAT P7b, one side of the planet is perpetually exposed to the searing heat of its star, while the other remains in total darkness. This stark contrast generates wind speeds that rival Earth's most intense tornadoes, creating conditions that would be utterly inhospitable to human life. Any probe sent to study this world would face the threat of being torn apart by these violent storms, as well as the overwhelming heat. The extreme climate variations on HAT P7b create some of the most unforgiving environments we can imagine. Survival on this planet, let alone exploration, would require technology far beyond what humanity has currently developed. Yet, despite these overwhelming challenges, the allure of such a world remains undeniable. HAT P7b, like Kelt 9b and other extreme exoplanets, serves as a reminder of the vast, unpredictable universe we seek to understand. And as we continue to push the limits of our technological and scientific capabilities, the mysteries of these planets will continue to inspire both awe and determination in equal measure. The composition of the atmosphere on HAT P7b adds yet another layer of peril to its already hostile environment. Scientists have detected clouds made up of molten rubies and sapphires, a stunning yet menacing sight. These findings suggest an atmosphere teeming with gases that could be life-threatening for humans. Imagine trying to breathe in an atmosphere so oppressive and toxic that every inhale could prove fatal without specialized life support. Venturing onto HAT P7b, then, is not only fraught with danger, it could very well be a death sentence for the unprepared. HAT P7b serves as a powerful reminder of the unpredictable and often brutal conditions that await humanity as we push the boundaries of space exploration. The extreme weather patterns observed on this distant planet underscore the profound difference between the comfort of Earth's hospitable environment and the harsh realities of alien worlds. In our search for new frontiers, this planet stands as a glaring example of the challenges we must overcome. Understanding the unique orbit of a planet is crucial for interpreting its atmospheric behavior. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the sun every year, The orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. While Earth completes one full orbit around the Sun every year, the orbits of other planets can vary greatly, leading to dramatic shifts in their environmental conditions. Some planets, like Mercury, have highly elliptical orbits that bring them closer to the Sun at certain points. As a result, they experience extreme temperature fluctuations, soaring daytime heat followed by bone-chilling cold during the night. These temperature swings can even cause lighter molecules in the atmosphere to be blasted into space, a phenomenon known as atmospheric escape. For any potential life forms on such a planet, this would be catastrophic, depriving them of the stability necessary for survival. Additionally, the axial tilt of a planet, its angle of rotation, has profound effects on its climate and weather. A planet with a significant tilt will have uneven distribution of sunlight, which creates temperature disparities that can fuel violent storms. On planets with sufficient gravity to retain thick atmospheres, these shifts can result in deadly weather patterns, including powerful cyclones, tornadoes, or even perpetual storms. Such extreme conditions would make any prolonged stay on these worlds perilous, as rapid climate shifts could quickly render the environment uninhabitable. The feedback loops set off by climate change only exacerbate this instability. As temperatures rise and ice melts, the surface becomes darker, absorbing more sunlight and further warming the planet in a vicious cycle. This means that if a planet's orbit fluctuates dramatically, it could trigger environmental changes so severe that even the most advanced ecosystems, or any form of life, would struggle to survive. Take, for example, Lon B, an exoplanet located in its star's habitable zone. At first glance, this seems promising for potential human habitation. However, its surface conditions present serious concerns. For one, Lon B is tidally locked, meaning one side always faces its star, while the other remains in perpetual darkness. This creates an extreme temperature contrast. The sunlit side could be unbearably hot, while the dark side may dip to temperatures that no human could withstand. This stark temperature dichotomy complicates the establishment of stable, livable environments. The atmosphere of Lon B is equally troubling. If it is thin or toxic, as some researchers speculate, it may not offer adequate protection against harmful cosmic radiation. Extended exposure to this radiation could seriously harm human health, making long-term habitation a dangerous prospect. Without a thick, protective atmosphere to shield against solar and cosmic rays, the risks of colonization escalate sharply. Moreover, Lon B's geological activity raises additional challenges. Planets in similar systems often experience significant volcanic and seismic activity, and Lon B may be no different. Such unpredictable geological phenomena could endanger any human structures or habitats. Volcanic eruptions or earthquakes could not only destroy settlements but also disrupt the climate, further destabilizing an already hostile environment. If Lon B harbors substantial bodies of water, these could fuel violent storms and flooding, adding yet another layer of risk to any would-be settlers. All these factors combine to make Lon B a highly dangerous candidate for human colonization. The potential for liquid water on the planet, while essential for life, also creates new dangers. The presence of water could bring about deadly weather systems, as large bodies of water often lead to intense storms and unpredictable flooding. Thus, the possibility of sustaining human life on Lon B, while theoretically exciting, is fraught with complex challenges that would require extraordinary technology and resilience. The extreme atmospheric pressures found on distant planets like those on the moons of gas giants present another formidable hurdle for human exploration. These pressures are a critical concern for the technology that would be needed to explore such hostile environments. As one descends into the ocean depths, the pressure increases with each passing meter. At these depths, the pressure can become many times greater than at the surface, placing immense strain on any equipment. Even the most advanced submarines or deep-sea vessels must be built with reinforced materials capable of withstanding such crushing forces. This includes thicker hulls, reinforced joints, and specialized pressure-resistant materials. The same challenges apply to planetary exploration, particularly when it comes to gas giants like Jupiter or its moons. These moons may harbor subsurface oceans beneath layers of ice, and any exploration mission would require landers and probes that can endure extreme pressure, freezing temperatures, and highly corrosive environments. Designing technology capable of surviving these conditions pushes the limits of engineering and material science, requiring continuous innovation. Each new discovery forces scientists and engineers to adapt, creating solutions that can survive and function under extreme environmental pressures. In the face of these technological challenges, the potential rewards are equally immense. The ability to develop equipment that can withstand these extreme conditions opens up possibilities for exploring some of the most remote and inaccessible environments in the universe. As our understanding of these alien worlds deepens, so too does our capacity to explore and ultimately make these places habitable, if the risks can be overcome. The atmosphere of a distant planet is one of the most critical factors when considering the viability of human exploration. Harmful gases, extreme weather, and radiation pose significant risks to astronauts. When studying these planets, scientists search for traces of toxic elements such as carbon dioxide, methane, or ammonia. These gases can severely affect human health, causing everything from respiratory problems to poisoning. An atmosphere lacking oxygen is just as dangerous, as astronauts would be unable to breathe without the aid of life support systems. The discovery of dangerous atmospheric conditions underscores the complexity of human space exploration. It's not just about getting to these planets, it's about surviving once there. The development of technology that can protect astronauts from these inhospitable conditions is just as critical as the journey itself. As we venture farther into the cosmos, the survival of future explorers will depend not only on our ability to reach new worlds, but also on our ability to adapt and thrive in the most extreme environments imaginable. Moreover, if scientists uncover powerful radiation fields or an atmosphere so thin that it exposes astronauts to the dangers of cosmic rays and solar flares, the consequences could be catastrophic. Such exposure may significantly increase the risk of severe health conditions, including cancer or acute radiation syndrome. This alarming potential for harm underscores the importance of extreme caution when selecting future destinations for human exploration. It highlights the necessity of thorough and rigorous evaluation of atmospheric data before launching any mission. This evaluation isn't just a matter of curiosity, it's a matter of survival. Understanding the composition of a planet's atmosphere does much more than satisfy scientific curiosity. It plays a pivotal role in determining the viability of human missions to that world. Space agencies are tasked with developing advanced technologies and strategies to protect astronauts from harmful environmental hazards, ensuring their safety and well-being while carrying out their explorative tasks. It's a delicate balance between curiosity and caution, where the thirst for knowledge must align with the imperative of preserving life. This balancing act is the crux of interplanetary exploration. One such intriguing yet forbidding target for future exploration is the exoplanet HD 29458b, more commonly known as Osiris. Situated roughly 60 light-years away in the constellation Pegasus, Osiris presents an array of challenges for space missions owing to its extreme weather conditions. The planet, a gas giant, experiences scorching temperatures and turbulent atmospheric conditions that make it an intimidating prospect for any exploratory mission. Surface temperatures soar beyond 1,000 degrees Celsius, creating an environment of intense heat that fuels violent and unpredictable atmospheric activity. The winds on Osiris are nothing short of ferocious, reaching speeds of over 8,000 kilometers per hour, reshaping the planet's clouds and creating an ever-shifting landscape filled with violent storms. For spacecraft attempting to study this distant world, the dangers are many. high-velocity wind currents present a significant risk, potentially hindering flight maneuvers, data collection, and overall mission success. But the environmental hazards don't stop there. The chemical composition of Osiris's atmosphere complicates the situation even further. The presence of water vapor, carbon monoxide, and other volatile compounds creates a perfect storm for extreme weather patterns. Atmospheric models predict that the combination of blistering heat and rapid winds could lead to the formation of enormous metallic clouds, generating storms that are entirely unlike anything observed in our own solar system. Understanding how these elements interact is a core aspect of the scientific inquiry surrounding Osiris, yet it presents substantial risks for spacecraft design and mission execution. Engineers will need to consider these hazards when developing instruments capable of surviving the planet's harsh conditions. Every aspect of the mission, from landing site selection to equipment durability, must be carefully planned to mitigate the challenges posed by high radiation levels and extreme temperatures. The conditions on Osiris will not only influence the technologies developed for exploration, but will also shape the approach taken by scientists in their pursuit of knowledge about this captivating exoplanet. Another fascinating yet challenging exoplanet is HAT P11b, which is particularly notable for its low gravity, just a fraction of Earth's. This reduced gravitational force presents a set of challenges and intriguing possibilities for human adaptability during exploration. In environments like that on HAT P11b, astronauts would experience a radically different sense of movement, as the body responds to the diminished gravitational pull in unexpected ways. Over time, the muscles and bones of astronauts could suffer atrophy and weakening, potentially compromising their physical abilities and long-term health. While the lower gravity might initially seem advantageous, allowing for easier movement and less effort in tasks like lifting and carrying, the long-term effects are more concerning. Without proper resistance training and physical conditioning, astronauts on HAT P11b could face significant declines in muscle strength and bone density. These changes might make returning to Earth or adjusting to different gravitational environments difficult, as the body would be less prepared for the increased gravitational forces. Furthermore, the effects of low gravity extend beyond the muscles and bones. Fluid distribution within the body would also be altered, potentially affecting blood circulation, vision, and various other physiological processes. These changes highlight the importance of understanding the human body's response to low-gravity environments and developing appropriate countermeasures. In preparation for future human missions to exoplanets like HAT P11b, extensive research will be necessary to devise strategies and technologies that can support astronauts' health and adaptability. Engineers will need to design specialized habitats, exercise regimens, and equipment that ensure astronauts can maintain their physical condition and performance during prolonged exposure to low gravity. Researchers will also be keen to develop methods that mitigate the potential adverse effects of these environments, helping astronauts thrive in conditions that are vastly different from those on Earth. The prospect of low-gravity exploration is exciting, but it presents unique challenges that must be carefully considered. In the breathtaking expanse of space, astronauts are often surrounded by a dazzling array of colors and visual phenomena. These vibrant hues, whether from the mineral compositions of planetary surfaces, the atmospheric conditions, or the way light interacts with foreign environments, can be both mesmerizing and disorienting. Planets like Mars and Venus, for example, are known for their striking red, orange, and blue landscapes, which can be inspiring, yet also create a strong sense of disorientation for those trying to navigate such alien terrains. This disorientation arises, in part, because our brains are wired to interpret visual information based on familiar earthly references. When astronauts are faced with unfamiliar colors and patterns like the swirling gas clouds on Jupiter or the intense red skies on Mars, their sense of direction can be compromised. The absence of familiar environmental cues makes it difficult to gauge distances or orient oneself, complicating navigation in these alien landscapes. To make matters worse, lighting conditions on other worlds often differ drastically from those on Earth. Shadows may fall in unfamiliar directions, or colors might blend in unexpected ways, adding to the confusion. The visual complexity of space exploration is as much a scientific challenge as a technical one, and astronauts must adapt to these unique environments while maintaining their spatial awareness and orientation. In the vast, uncharted territories of space, the environments of distant planets and moons present challenges that would baffle even the most experienced astronauts. For instance, when navigating alien landscapes, astronauts must grapple with optical illusions that alter their perception of space. Atmospheric refraction, a phenomenon where light bends as it passes through different layers of air, can distort how objects are perceived. Distant features may seem closer, and the overall sense of depth can be misjudged. These deceptive visual cues, often caused by the unique atmospheric conditions of distant worlds, complicate the already demanding tasks of piloting spacecraft or traversing alien terrains on foot. Astronauts, accustomed to relying on their eyes in Earth's environment, must adapt by prioritizing their instruments and signals over visual clues. In such unfamiliar realms, precision becomes paramount. As humans push the boundaries of space exploration, understanding and preparing for these sensory challenges caused by vibrant colors, unusual lighting, and shifting perspectives becomes a crucial part of astronaut training. Only through such preparation can they navigate these strange new worlds with safety and confidence, mitigating the risk of disorientation that may arise from unexpected environmental factors. Take, for example, the exoplanet PDS-70b. Situated in the constellation Centaurus, this planet lies about 130 light-years from Earth. At first glance, it might seem like any other gas giant, but its characteristics set it apart in ways that both intrigue and concern scientists. PDS-70b is massive, roughly 6 times the mass of Jupiter, and it resides within a protoplanetary disk, a swirling, chaotic environment filled with gas and dust. The conditions surrounding this planet are nothing short of extreme, making it an ideal subject for study. One of the most striking features of PDS-70b is its composition. The planet's atmosphere is predominantly made up of hydrogen and helium, yet researchers have detected traces of carbon monoxide and other complex molecules. This mixture suggests that the planet's weather patterns could be intensely volatile, with violent storms raging across its surface. Its unusual brightness hints at the fact that PDS-70b is still in the process of formation, actively drawing in material from the surrounding disk. This continuous accumulation could lead to the expulsion of debris and other hazardous materials into space, potentially posing a risk to nearby celestial bodies. Perhaps one of the greatest concerns about PDS-70b is its extreme temperature. The planet is thought to experience temperatures far higher than anything found on Earth, raising questions about how materials would behave under such intense heat. Would they evaporate, melt, or undergo some other transformation? This unpredictable environment is fraught with dangers, as the planet's volatile atmosphere could lead to exotic phenomena that humans are not equipped to handle. Should any of these processes affect nearby planets or regions of space, the consequences could be catastrophic. As a gas giant situated in a young star system, PDS-70b's gravitational pull could also have significant consequences for nearby smaller bodies. Its immense gravity could alter the orbits of these objects, potentially leading to collisions. This gravitational influence, combined with the planet's ongoing formation, creates a chaotic and unstable environment, making it an area of both scientific fascination and concern. Exploration of such a world, especially one in a binary star system, presents a host of environmental challenges. Unlike our solar system, where the sun is the sole provider of light and warmth, a dual star system like the one that PDS-70b is part of introduces an entirely new set of conditions. The gravitational forces exerted by 2 stars can create unpredictable weather patterns, including rapid temperature shifts that swing from intense heat to sudden cold. Such fluctuations could threaten the survival of any human explorers, as they would have to contend with not only extreme weather, but also the potential malfunction of their equipment due to these erratic conditions. The complexities of the day and night cycles in a binary star system are another crucial factor. With 2 stars, the length of day and night can vary significantly, and some areas may experience long stretches of daylight, while others could plunge into darkness unexpectedly. This irregularity would make it challenging to establish a predictable routine, essential for maintaining circadian rhythms and managing energy levels. Such inconsistencies could leave astronauts vulnerable to fatigue, disorientation, and diminished mental clarity, further complicating their mission. Moreover, the gravitational interplay between the two stars could also generate seismic activity, shaking the planet with quakes or volcanic eruptions. Such geological instability poses a significant threat to any potential explorers. The constant shifting of the planet's crust, coupled with the changing radiation levels from the stars, could increase the risk of radiation sickness or even cancer. These hazards add yet another layer of complexity to the already perilous task of exploring a world in a binary star system. Then there is TOI 849b, another fascinating and challenging exoplanet that has captured the attention of scientists. Unlike PDS 70b, TOI 849b is classified as a super-Earth, meaning it is larger than Earth, with a core thought to be primarily composed of heavy metals such as iron and nickel. This dense core, while contributing to the planet's massive size, could result in gravity levels much higher than those experienced on Earth. For astronauts, this increased gravity would make every movement and task more physically demanding, possibly leading to long-term health complications. The dense core of TOI 849b also suggests that the planet could experience significant geological instability. Volcanic eruptions or seismic events are likely, and the volatile nature of the environment would put any exploration team in constant danger. To survive here, explorers would need sophisticated technology and advanced protective measures. Their safety would rely heavily on their ability to prepare for the unpredictable forces that shape this world. As with other extreme exoplanets, the challenges of exploring TOI 849b are not just physical, but technological. The planet's inhospitable atmosphere, its high gravity, and the risk of geological disasters would demand the very best in engineering and planning. A successful mission would require not only state-of-the-art equipment, but also a deep understanding of the environmental factors that could compromise the health and safety of astronauts. Each of these exoplanets, PDS 70b, TOI 849b, and others, illustrates the profound dangers and mysteries that await in the far reaches of space. They remind us that the universe is full of unknowns, where every new discovery could lead to a new set of challenges. For humanity to continue its journey into the cosmos, it must prepare for the unexpected, armed not just with technology, but with the knowledge to navigate the unknown. The atmospheric conditions surrounding TOI 849b present an array of formidable challenges. Extreme temperatures, intense pressure, and the possible presence of toxic gases create an environment that would be difficult to navigate for any exploratory mission. These harsh elements, coupled with gravitational and geological risks, form a daunting backdrop for our understanding of this distant exoplanet. As we continue to probe the mysteries of this fascinating world, the obstacles it presents only magnify the awe and curiosity that it stirs in our minds about the far reaches of the universe. Rapid fluctuations in temperature on Earth have already demonstrated how profoundly they can impact human missions, particularly in the context of space exploration and scientific research. Sudden temperature shifts pose significant threats to technology, compromising the very equipment that enables successful missions. Instruments designed to collect essential data or support human life come with specific operational thresholds. When temperatures fluctuate unexpectedly, these instruments may fail, resulting in compromised mission goals or, in the worst-case scenario, a complete mission failure. In addition to these technological concerns, human physiology also becomes a crucial factor. The human body is finely tuned to maintain internal stability, but extreme heat or cold can induce severe physiological stress. Astronauts and researchers who face sudden shifts in temperature risk dehydration, heat exhaustion, or hypothermia. For instance, if temperatures within a spacecraft or a research base fluctuate too dramatically, the crew may struggle to regulate their body temperature. This makes them vulnerable to heat-related illnesses or cold-induced hypothermia. These rapid changes don't just threaten the crew's health, they also complicate the logistics and planning of space missions. Whether launching from a spaceport or conducting experiments on another world, any climate-related disruptions can delay operations, require additional resources, or even change the timing of critical activities. These uncertainties not only carry a hefty financial cost, but could also lead to lost scientific discoveries, extended exploration timelines, and, in the worst case, mission failure. Managing these risks is therefore vital. Adequate preparation, cutting-edge technology, and well-established emergency protocols are essential to ensuring the success of human missions. Our ability to navigate the unpredictable and ever-changing environmental conditions of space will be a cornerstone in humanity's quest for exploration and discovery. In another part of the universe, WASP-33b poses an equally challenging scenario, albeit for an entirely different reason. Located approximately 170 light-years away, this exoplanet is a prime example of what is known as a hot Jupiter, a category of gas giants that orbit perilously close to their parent stars. As a result, WASP-33b is subject to extreme temperatures that soar far beyond the limits of what any known life form could endure. Temperatures here can reach as high as 2,700 Celsius, a level of heat that would immediately destroy any biological organism as we understand it. This searing heat not only makes the possibility of life on WASP-33b highly improbable, but also raises profound questions about the nature of life itself. Water, a vital component for life on Earth, would not remain in its liquid form. It would vaporize the moment it encountered the intense heat. This means that the very foundation for life as we know it would simply cease to exist in any recognizable form. The planet's turbulent atmosphere, charged with powerful storms and relentless winds, further complicates the situation. Atmospheric stability, a key factor in supporting life, is virtually non-existent. The ferocious elements on WASP-33b would make it nearly impossible for life to find refuge in any form. The combination of extreme temperatures and volatile weather makes the existence of life, as we understand it, not just improbable, but virtually impossible. Yet, the extreme conditions of WASP-33b also serve to spark deeper questions about the universe. Could life, in some form we cannot yet comprehend, exist in such an environment? Or would life need to adapt in ways that challenge our very definitions of biology? As we explore further, each new discovery adds to the complexity of the story we are beginning to understand about life beyond our planet. Exploring worlds like T-849b and WASP-33b not only pushes the boundaries of our technology and capabilities, but also deepens our understanding of what it means to survive, and perhaps what it means to live in the vast expanse of space. Each challenge encountered in the pursuit of knowledge is a testament to humanity's unyielding curiosity and our desire to answer the profound questions about our place in the cosmos. WASP-33b's extreme proximity to its star subjects it to powerful tidal forces, generating intense gravitational effects. This results in tides that could rival those found in the most active volcanic environments on Earth, leading to an atmosphere that is both chaotic and unstable. In such an environment, any potential biochemistry could be deeply disrupted. Life, which often relies on stable conditions to evolve and thrive, would face insurmountable challenges on this hostile planet. This insight compels us to rethink our understanding of what makes a planet habitable. While Earth shares vital characteristics with certain exoplanets, the existence of life might not always adhere to the conditions we once considered necessary for its survival. The extreme conditions on WASP-33b challenge us to expand our definitions of habitability, urging us to consider a broader range of planetary environments in the search for life. WASP-33b's fierce winds create sound patterns unlike anything found on Earth. These alien noises offer a fascinating glimpse into the planet's atmospheric conditions. Located about 10,000 light-years away in the constellation Cygnus, WASP-33b is classified as a hot Jupiter. This means it is a gas giant that orbits dangerously close to its star, resulting in blistering temperatures and severe atmospheric turmoil. These extreme winds can reach speeds exceeding 600 miles per hour in certain areas. As these violent winds rush and collide with one another, they produce a cacophony of sound waves. These sounds reverberate through the planet's thick atmosphere and are analyzed by scientists using spectroscopic data. Through this, they create simulated auditory landscapes, offering a surreal, otherworldly soundscape that feels almost alive. When we think of terror, our minds often connect unsettling noises with fear. The strange sounds generated by WASP-33b's turbulent winds may evoke a primal sense of dread in those who encounter these simulated waves. Just as certain frequencies on Earth can trigger anxiety or discomfort in humans, the alien sounds of this distant world could provoke similar reactions. The raw power of these winds, combined with the mystery surrounding them, could amplify our inherent fear of the unknown. This exploration of alien soundscapes not only takes us deeper into the cosmos, but into our own psychology. By analyzing these extreme phenomena, we might uncover echoes of humanity within the vast universe. The allure of the unknown mingles with our intrinsic reactions, reminding us that the universe is full of secrets capable of challenging our understanding and stirring our deepest fears. Meanwhile, the potential for radiation on GJ321b presents a daunting challenge for any would-be explorers. Located in a star system where its host star, a red dwarf, regularly emits intense solar flares and hazardous bursts of ultraviolet and X-ray radiation, GJ321b is an environment fraught with peril. Unlike our Sun, which follows a predictable solar cycle, red dwarfs are capable of producing erratic and powerful emissions, making the radiation conditions on GJ321b unpredictable and dangerous. Explorers on this exoplanet would be exposed not only to cosmic radiation, but also to the harmful radiation from the star itself. Such exposure could lead to immediate and long-term health risks, including radiation sickness, cancer, nervous system damage, and severe skin burns. In light of these dangers, any mission to GJ321b would require extensive protective measures. Advanced shielding technologies would be crucial, including spacecraft materials designed to block harmful radiation and habitats on the planet's surface that are either buried under layers of soil or situated in natural shelters like caves. Life support systems would need to be meticulously monitored, and explorers might also require pharmaceuticals to counter the acute effects of radiation exposure. As our understanding of radiation and its potential impacts continues to evolve, future missions must include comprehensive health protocols, including exposure monitoring and emergency evacuation plans in the event of acute radiation effects. The exploration of GJ321b holds immense scientific promise, but the unpredictable nature of its radiation environment serves as a stark reminder of the risks of venturing beyond our home planet. On GJ321b, scientists speculate that bizarre geological formations might haunt the landscape, captivating and unsettling any human visitors. This planet, located about 50 light-years away in a binary star system, offers an unusual mix of environmental conditions. The intense atmospheric pressure and extreme temperatures could foster the creation of strange structures, sharp, jagged peaks, or vast canyons carved by relentless winds and complex chemical processes unlike anything seen on Earth. One of the more chilling possibilities involves the formation of alien crystals that grow in strange shapes, reflecting the peculiar chemical composition of GJ321b's atmosphere. These crystals could shimmer under the light of the twin stars, creating a surreal visual effect that might be as beautiful as it is unsettling. Their sharp, angular shapes could suggest a world where life has evolved in radically different ways, leaving human visitors with an overwhelming sense of unease as they navigate these alien landscapes. The eerie nature of these formations, combined with the extreme environmental conditions, would challenge any human explorer's sense of comfort. The unpredictable winds and unusual atmospheric phenomena make GJ321b a truly hostile, yet fascinating world. One that might not only challenge our technological limits, but also provoke profound questions about the limits of human endurance and our understanding of life's potential forms. Exploring such a planet would not only push the boundaries of space exploration, but also force us to confront the mysteries of life itself and its ability to survive in the most extreme conditions. As human curiosity pushes further into the cosmos, the quest to explore distant exoplanets brings us face to face with worlds unlike anything we've encountered before. One such world is GJ321b, an enigmatic planet that beckons with its alien features and starkly different geological landscape. Imagine stepping onto its surface, where towering volcanic structures rise majestically against the horizon. These colossal volcanoes, products of the planet's most geological activity, have the potential to unleash not only molten lava but also gases that could obscure the sky, creating an eerie haze that cloaks the land in mystery. The atmosphere of GJ321b is no less perplexing, with the possibility of these volcanic eruptions sending clouds of strange, toxic gases swirling through the air. Distant eruptions could reverberate across the plains, the rumble echoing through the silence, adding a haunting soundtrack to the surreal landscape. The very sound of these eruptions, deep, vibrating, and resonating from beneath the surface, might create an unsettling feeling, like as though the planet itself is alive and shifting. The echoes could amplify a sensation of something unseen, lurking just beneath the surface, waiting to be uncovered. For any explorer setting foot on GJ321b, the world they step into is completely alien, yet strangely beautiful. Every rock formation, every crevice is a testament to the planet's violent past and its ongoing transformation. The landscape is foreign, harsh, and utterly captivating, forcing visitors to confront the mysteries that arise from a world existing under conditions so extreme that they are beyond our imagination. The psychological effect of such an environment would be profound. The grandeur of the geological features could evoke a sense of awe, while simultaneously instilling a deep-seated fear of the unknown. Each explorer might find themselves overwhelmed not just by the planet's majesty, but by the realization that the forces at work here are completely outside the bounds of human understanding. For those daring enough to venture into this strange land, the allure of discovery would be tempered by the ever-present reminder of just how little we know about the many worlds that dot the universe. Far from the peaceful, life-supporting conditions we enjoy on Earth, other exoplanets present even more pressing dangers for human explorers. 55 Cancri d, located around 40 light-years from our home planet, is one such world, known for its extreme and volatile conditions. This planet, classified as a super-Earth, is not just larger than our own world, it is also a place where the very fabric of the atmosphere presents a series of challenges to human survival. Though the planet's surface is thought to be rocky, its atmosphere is where the real danger lies. Astronomers have identified 55 Cancri d as a world of fierce and unpredictable storms, capable of reaching violent speeds that could rival the most dangerous weather systems on Earth. These storms are not only dangerous in their sheer power, but also in their complexity, posing challenges for both spacecraft and the people who rely on them. The atmosphere's pressure is significantly greater than Earth's, which means that explorers could face crushing forces that would be unimaginable in our daily lives. These extreme pressures would be amplified by winds moving at speeds that could easily dismantle any human-built structure. The rapid temperature fluctuations on 55 Cancri d add another layer of peril to its environment. Orbiting closely to its parent star, the planet experiences intense heat. When combined with the violent storms, these temperature extremes could wreak havoc on life support systems, forcing scientists to reconsider how human technology could withstand such forces. Additionally, storms on the planet may generate lightning, a phenomenon that would only add to the already formidable dangers of the world. The unpredictable nature of these storms would make any attempt at exploration a high-stakes venture, demanding that human ingenuity and technology rise to meet challenges that are not yet fully understood. But the challenges of space exploration don't end with atmospheric conditions. The gravitational forces exerted by different planets also present significant obstacles to explorers. Within our solar system, each planet has its own gravitational characteristics, which influence how missions are planned and executed. Mars, for instance, has only about 38% of Earth's gravity. While this reduced gravity could make movement easier and less physically taxing, it also brings with it a whole new set of challenges. Astronauts must adjust to a different set of physical demands, and the equipment used must be designed to function in this low-gravity environment. Rovers, for instance, must be lightweight and agile to navigate the rocky Martian terrain without being bogged down by their own weight. However, the difficulties only intensify when considering gas giants like Jupiter. With their immense gravity, a lack of solid surfaces, and crushing atmospheric pressures, these planets pose challenges that stretch the limits of what current technology can handle. On Jupiter, exploring would require equipment capable of withstanding pressures so great that they could crush most materials. The very idea of landing on such a planet becomes almost irrelevant, as any attempt at building a habitable structure would face nearly insurmountable hurdles. Instead, the focus might shift to the possibility of aerial or floating stations operating above the planet's crushing depths. The unique gravitational environments on each of these planets require profound adjustments in the design of spacecraft and habitats, as well as a rethinking of how astronauts move and operate in these environments. Space exploration, after all, is not just about reaching new frontiers. It is about adapting human technology and abilities to worlds where even the most basic aspects of survival are magnified and complicated by alien forces. Beyond our solar system, exoplanets like Proxima Centauri c, an intriguing world orbiting the closest star to our own, present their own unique challenges. Proxima Centauri c is a super-Earth, which means it is larger than Earth, but lacks many of the features that could support human life. One of the most significant hurdles in exploring Proxima Centauri c is its exposure to intense stellar radiation from its parent star, Proxima Centauri. As a red dwarf, Proxima Centauri frequently emits powerful flares that can strip away atmospheres and bombard planets with intense radiation. For human explorers, this radiation poses a serious risk, with potential long-term health effects, including an elevated risk of cancer and other illnesses related to radiation exposure. There is also the question of what the planet's atmosphere might contain, assuming it even has one. The atmosphere of Proxima Centauri c could be toxic or lack the necessary elements, like oxygen, that are essential for human life. This would create a formidable barrier to any attempts at colonization or sustained exploration. Scientists are still piecing together the puzzle of this distant world, but one thing is clear. Proxima Centauri c represents both a challenge and an opportunity, one that requires us to think deeply about the limits of human endurance and technological advancement in the face of hostile, unfamiliar environments. Each of these planets, from GJ 321b to Proxima Centauri c, reminds us of the complexities of space exploration. They are not merely distant dots in the sky, but worlds that hold the potential for discovery, albeit with enormous challenges. These worlds force us to reconsider our assumptions about life beyond Earth, our reliance on technology, and the resilience of the human spirit in the face of seemingly insurmountable odds. As we push further into the universe, we are not just testing the limits of our machines, but also the very limits of what it means to be human in the vast, uncharted reaches of space. The challenge of exploring distant exoplanets goes beyond technological prowess. It delves into the fundamental question of whether humans can even survive the harsh and unpredictable conditions that might await them. In particular, Proxima Centauri c, an exoplanet that orbits the closest star to our solar system, raises concerns that extend far beyond the capabilities of current space exploration. The very nature of this world, with its unknown atmosphere and potential environmental hazards, challenges our understanding of habitability on a cosmic scale. Furthermore, the planet's gravity, coupled with the possibility of extreme atmospheric pressure, may not support human survival. This presents serious implications not only for long-term habitation, but even for short-term missions, such as exploratory landings or brief visits. The environment of Proxima Centauri c could be so inhospitable that it might render any human presence impossible without significant advancements in life support technologies. Understanding the nature of this planet's atmosphere will be crucial if we are to consider any future missions to this nearby world. Without the development of systems capable of mitigating extreme environmental risks, sending humans to Proxima Centauri c remains a distant aspiration, a dream that may be far beyond our current capabilities. Proxima Centauri c, like many exoplanets within the habitable zone of their stars, has become a subject of great interest. Its potential to harbor life or to serve as a base for future human exploration is tantalizing. However, its status within the habitable zone doesn't guarantee conditions we might expect from a temperate, Earth-like climate. In fact, the reality could be far harsher than anticipated. This exoplanet could be subject to extreme weather phenomena with unpredictable temperature fluctuations, violent storms, and erratic precipitation that pose significant threats to explorers. One of the most complex challenges in exploring Proxima Centauri C lies in the unpredictability of its weather patterns. Should scientists discover that the planet experiences sudden storms, high winds, or torrential rain, the safety of any human mission could be compromised. These weather extremes would not only pose challenges for landing and taking off, but also impact daily activities on the planet's surface. Traveling between habitats could become a dangerous endeavor, as would the collection of resources crucial for survival. Furthermore, such conditions could disrupt scientific experiments and hinder exploration efforts, reducing the planet's potential as a site for research. If atmospheric pressure and temperature fluctuations on Proxima Centauri C occur frequently, life support systems aboard spacecraft and habitats would need to adapt in real time to ensure astronaut safety. The complexity of these systems, designed to monitor and regulate environmental factors, would be tested like never before. A failure in any of this advanced equipment, especially in the face of severe weather, could have dire consequences. The risks would be considerable, as astronauts would find themselves vulnerable to the unpredictable whims of the planet's climate. These challenges require careful consideration, meticulous preparation, and constant vigilance. Advanced training, predictive weather models, and robust, resilient equipment would be vital for any crew brave enough to embark on a mission to Proxima Centauri C. Yet, even with these preparations, the planet's weather would remain a formidable opponent. The pursuit of exploration would require not only technological innovation, but also mental and physical fortitude. Astronauts would need to be equipped to handle not just the technical demands of space travel, but also the harsh, sometimes hostile environment of a world that may not be forgiving of human presence. On the other side of the cosmic spectrum lies planet X01b, another exoplanet that presents one of the most extreme environments we have encountered. Located approximately 51 light-years from Earth, X01b orbits a star similar to our Sun and boasts an atmosphere composed primarily of hydrogen and helium. The surface temperatures of X01b soar to unbearable heights, often exceeding 1,000 degrees Fahrenheit. Such relentless heat, combined with high atmospheric pressure, creates an environment where human life would be unsustainable without technological safeguards, far beyond what we currently possess. Exploring X01b would require explorers to don heavy, specialized suits designed to withstand the extreme atmospheric conditions. However, these suits would not be a mere shield. They would become a constant reminder of the limitations imposed by the planet's oppressive environment. The thick, heavy air would feel suffocating, encasing explorers in an atmosphere that mimics a psychological cage. Every breath they take would be controlled, filtered, and regulated, intensifying the sense of confinement. The physical weight of the suit, coupled with the crushing pressure of the atmosphere, would create a sense of claustrophobia that could overwhelm even the most seasoned astronaut. With exceedingly limited visibility, the explorers would be isolated not just physically, but also mentally, from the familiar world they once knew. The environment of X01b is not just hostile in its physicality, it is a constant psychological challenge as well. The combination of extreme heat, high pressure, and an unrelenting atmosphere would transform the experience of exploration into an ordeal. The sense of being cornered, unable to escape, would hang heavily over the explorers' thoughts. The overwhelming heat and pressure would affect their senses, creating a near-constant bombardment of stimuli that makes it impossible to feel at ease. With each step, they would be reminded of the fragility of their existence, as the oppressive atmosphere pushes them further into a state of isolation and mental strain. Despite the technological advancements needed to survive, the mental toll of such an environment cannot be overlooked. The pressure, the heat, the sense of confinement, and the overwhelming weight of isolation would shape the perception of space exploration. X01b, with its forbidding landscape and atmosphere, serves as a reminder that the pursuit of exploration often requires not only physical resilience, but also the mental fortitude to endure the unknown. For any human mission to exoplanets such as X01b, the challenges would extend beyond the technical. They would force us to confront the limits of human endurance and the psychological costs of exploration. As scientists continue to explore the potential of these distant worlds, the daunting realities of extreme weather, oppressive atmospheres, and the inhospitable conditions of these planets will remain central to any conversation about humanity's future in space. These worlds may one day provide answers to the fundamental question of whether life can thrive elsewhere in the universe. But for now, they stand as stark reminders of the fragility of human life and the complexities of space survival. The atmosphere of X01b is believed to be thick, dense, and laden with corrosive gases. Violent storms and frequent lightning are expected to erupt from this atmosphere, creating unpredictable and hazardous weather conditions. Such extreme phenomena would hinder visibility, making it difficult for atmospheric vehicles to navigate. These tempestuous weather patterns would not only complicate landing procedures, but could also lead to dangerous, erratic flight paths for any vehicles attempting to approach or explore the planet. A human mission to X01b would need to account for these challenges, as the storms and unpredictable weather could delay launches, endanger safety, and complicate any efforts to establish a sustainable presence on the planet. Moreover, the gravity on X01b is vastly different from Earth's. This factor, when combined with the planet's high-pressure atmosphere, would result in altered weather dynamics. Heavier rains and more turbulent winds would be a common occurrence. These extreme conditions, alongside the unpredictable weather, would create a harsh environment for landing and long-term survival. The ongoing risks to life support systems and the integrity of habitats designed for human habitation would further complicate any mission to X01b. Understanding these severe hazards highlights the need for extensive technological advancements and research before considering any manned mission to this planet. As humanity continues to explore the cosmos, grasping the implications of extreme weather on distant worlds is crucial for ensuring the success and safety of future interstellar endeavors. K21-141b, an exoplanet located roughly 130 light-years away from Earth, presents its own unique set of challenges. Tidal locking has caused one side of the planet to constantly face its star, while the other side remains in perpetual darkness. This strange rotational pattern leads to intense tidal forces that significantly affect the planet's surface and atmosphere. The gravitational pull from the nearby star has generated extreme temperatures on the planet's day side, reaching up to 2,500 degrees Celsius. Such temperatures are hot enough to vaporize metals and turn the surface into a molten landscape. Conventional spacecraft and rovers would find it nearly impossible to survive on this hostile surface. Any exploration mission to K21-141b would require cutting-edge technologies and materials capable of withstanding not only the extreme heat, but also the corrosive environment likely present due to the atmospheric conditions. On the night side of K21-141b, the lack of sunlight causes the temperatures to plummet, leading to freezing cold conditions that could cause volatile compounds in the atmosphere to freeze or react dramatically. The stark temperature differences between the two sides of the planet would create challenges for exploration, requiring any equipment to be specially designed to handle rapid and extreme shifts in temperature. This adds yet another layer of complexity to any mission to K21-141b. In addition to these environmental extremes, the planet's tidal forces also affect its geological activity. Volcanic eruptions are likely to be more frequent due to the continuous strain exerted by the planet's gravitational forces. These eruptions would release ash and gases into the atmosphere, further complicating any exploratory missions and contributing to the already unstable landscape. The combination of extreme temperatures, active geology, and the constant environmental stress makes K21-141b a particularly challenging yet fascinating target for scientific exploration. Any future missions to this planet would require innovative approaches to study its geology, atmosphere, and potential for sustaining life, if it could exist in such extreme conditions. K21-141b, another exoplanet located approximately 250 light-years away, presents a similarly terrifying environment. The surface of this planet is completely covered in molten lava, the result of intense heat caused by its close orbit around its host star. Temperatures soar to around 2,500 degrees Celsius, creating an environment where metal would melt and solid ground would be an impossibility. The surface is dominated by vast oceans of liquid rock that constantly shift, creating a nightmarish version of Earth's volcanic landscapes. These molten seas stretch far into the horizon, presenting a formidable challenge for any researchers attempting to understand the planet's formation, composition, and geological history. The extreme nature of K2-141b's surface raises significant questions about the possibility of life. Could life survive in such an extreme environment? If so, how would it adapt to the harsh conditions of molten seas and intense temperatures? These questions are key to understanding not just the potential for life on this planet, but also the broader implications for life in other extreme environments across the universe. Despite the daunting challenges it poses, K2-141b offers a unique opportunity to explore the limits of planetary science and the resilience of life in the most extreme environments imaginable. On the distant planet K2-141b, an astonishing phenomenon occurs: tidal locking. This means one side of the planet is eternally facing its star, creating a dramatic contrast between the scorching heat of the perpetual day and the frigid cold of the never-ending night. The daytime environment, where temperatures can soar to unbearable extremes, stands in stark opposition to the nighttime zone, which, though cooler, remains just as unforgiving. This unusual divide gives rise to two entirely distinct ecosystems that exist in a precarious balance. But with such extremes, the challenge of exploring this alien world becomes a daunting task. Scientists must theorize about the atmospheric dynamics and the complex chemical reactions that could arise in such an environment. The contrast of these harsh conditions offers a vivid glimpse into the diversity of planetary environments far beyond our solar system. Every new discovery, like K2-41b, stretches the limits of our understanding of what makes a planet habitable or even survivable. The ability to study such intimidating worlds allows us to unlock the mysteries of planetary systems, providing invaluable insight into their formation and evolution over the vast expanse of the cosmos. Yet the planet's partially molten surface creates an enormous obstacle for human exploration. This surface, which remains unstable and volatile, raises serious concerns regarding safety and mission feasibility. Scientists warn that K2-141b's surface is prone to rapid destabilization, potentially leading to violent geological activity, such as eruptions or dramatic shifts in the landscape. Such unpredictability makes it extremely dangerous for any explorers daring enough to set foot on this hostile terrain. The dangers extend far beyond just the extreme heat. The temperature fluctuations are so severe that any exploration equipment or human habitats would need to be built with exceptional resilience. These materials must be capable of withstanding not only blistering heat, but also the danger of molten material that could spill or pool in areas where explorers may be working. The engineering required for such equipment becomes significantly more complex, demanding cutting-edge technologies and materials to survive in conditions where less robust structures would be easily destroyed. Even the fundamental act of navigation presents a challenge. The partially molten terrain makes traditional landing and mobility methods obsolete. Molten rock flows and shifting landscapes complicate every aspect of movement, creating a need for real-time monitoring and unparalleled adaptability in the mission's execution. The complexity of planning, landing, and conducting exploration on such a volatile surface cannot be overstated. But the hurdles do not stop at the immediate dangers. There are also the long-term implications of exploration. Will humans ever be able to create self-sustaining habitats on such an unstable world? Can we develop systems that ensure the safety of astronauts while still allowing for meaningful scientific discovery? These critical questions remain unanswered, and only time and careful innovation will reveal whether it's possible to unlock the secrets beneath the molten surface of K2-141b. Located approximately 240 light-years from Earth, K2-141b is classified as a lava world, a term that captures the intensity of its molten surface, with temperatures that can soar as high as 3,000 degrees or Fahrenheit. This extreme heat presents a constant threat to physical well-being, but it also cultivates a unique psychological burden for any hypothetical explorers. The harsh conditions could foster a constant sense of impending danger, heightening anxiety and forcing explorers to remain vigilant at all times. But the dangers do not end with heat. The atmosphere of K2-41b adds another layer of peril. Composed mainly of sodium and potassium, the thick atmosphere leads to flash evaporation and produces harmful gases that could make survival even more difficult. For anyone brave enough to visit, these toxic conditions would make the planet's surface a terrifying place to navigate. The constant threat of harm could invoke a deep sense of helplessness and fear, especially as the explorer would be far from home and isolated in a dangerous alien environment. Furthermore, the planet's atmospheric pressure far exceeds what humans are used to, making the conditions even more extreme. Such pressure would cause physical discomfort and mental strain, potentially leading to sensations of suffocation or confinement. The oppressive environment would also increase the risk of claustrophobia, as explorers would constantly feel the weight of isolation, knowing that they are millions of miles from Earth with no immediate hope of escape. The crushing atmosphere would also exacerbate feelings of psychological distress, further intensifying the already grueling conditions. Adding to the mental burden, the unpredictable volcanic activity on K2-141b would constantly change the landscape. Frequent eruptions and molten lava flows create an ever-shifting environment, requiring explorers to stay alert at all times. The unrelenting threat of sudden geological shifts could easily lead to fatigue and burnout. The mental toll of living in such an unpredictable world would be staggering, adding a significant layer of complexity to any mission planning. But K2-141b is not the only harsh world on the frontier of human exploration. Another planet, LHS 582b, presents its own set of unique challenges. Unlike Earth, this exoplanet lacks a protective atmosphere, exposing any potential visitors to the raw, unforgiving elements of space. Cosmic radiation, which is usually absorbed by an atmosphere, would bombard anyone attempting to explore the planet's surface, increasing the risk of cancer and other serious health problems. The absence of atmospheric pressure adds yet another threat to human survival. Without an atmosphere to regulate pressure, liquids like water would boil away at lower temperatures. This would make it impossible to retain liquid water on the planet's surface unless contained within pressurized containers. This absence of a breathable atmosphere would complicate colonization efforts, requiring advanced technology and careful planning just to meet basic survival needs. Both K2-141b and LHS 582b reveal the extremes of what is possible in planetary environments. They push the boundaries of our imagination, challenging us to rethink what makes a world habitable. As our exploration of the cosmos continues, these alien worlds remind us of the infinite variety of conditions that exist beyond Earth, and the immense hurdles we must overcome to understand and, perhaps one day, explore them. The absence of an atmosphere on LHS 582b creates a perilous reality for any potential explorers. Without the protective envelope of air, this distant exoplanet faces extreme temperature swings, making the landscape both fascinating and dangerous. During the day, temperatures could soar to unbearable heights, while at night, they would plummet to frigid lows. This stark contrast would place any human inhabitants at risk, demanding the creation of specially designed habitats. These shelters would need to provide not only thermal control, but also protection from the relentless solar winds that bombard the planet's surface. The rugged terrain, coupled with these environmental hazards, creates daunting challenges for any mission aimed at exploring this distant world. A mission to LHS 582b would require the most advanced technology, meticulous planning, and a deep understanding of how to protect astronauts from the planet's hostile conditions. The potential risks go far beyond temperature fluctuations, as the surface of this exoplanet could harbor toxic substances. Imagine stepping onto an alien world only to discover that the soil and rocks beneath your feet contain harmful elements. This scenario could turn the fantasy of exploration into a hazardous reality, posing significant threats to the health and safety of the crew. The risk of toxicity from naturally occurring compounds or remnants of past activities, like mining or chemical processes, would make the mission all the more perilous. Some toxic substances could cause immediate health effects, while others might have long-lasting consequences, such as contamination of life support systems or equipment. This danger goes beyond the astronauts' immediate well-being. The potential contamination of the planet could disrupt future exploration efforts for generations to come. The last thing scientists want is to introduce Earth-based microorganisms into an alien ecosystem, potentially endangering any indigenous life that might exist or harming a pristine environment. In light of these challenges, the need for advanced technology is critical. Engineers would need to design habitats and protective suits capable of shielding explorers from both the physical hazards of the environment and the threat of toxic substances. Specialized tools would be required to analyze the surface, identify hazardous materials, and understand their impact on the health of the crew and the integrity of the mission. This added complexity would raise the cost and logistical demands of the mission, making the dream of exploring LHS 582b seem more distant and fraught with risk. The discovery of toxic substances on such a planet could fundamentally alter our understanding of its history. If these elements were once part of a thriving ecosystem, it would open new avenues for scientific investigation, sparking debates about what conditions might have existed. However, the realities of exploring such a hazardous world would force future missions to approach with extreme caution and respect for the unknown. Similarly, GJ-132b, an exoplanet located about 41 light-years away in the constellation Vela, presents an equally captivating yet alarming scenario. This rocky world orbits its star closely, subjecting its surface to extreme temperatures and frequent volcanic activity. The relentless geological processes at play could constantly reshape the surface, potentially making the planet a land of chaos and fire. Imagine a world where volcanoes rage continuously, spewing lava and toxic gases into the atmosphere. For any human explorers, this would create an environment fraught with danger. The threat posed by active volcanoes on GJ-132b is not to be underestimated. Eruptions could endanger spacecraft, damage equipment, and create severe health risks for astronauts. The unpredictability of volcanic eruptions would add an element of uncertainty to any mission, transforming a planned exploration into a race for survival. Such an environment would require the most advanced technology and innovative strategies to navigate. A world where the land is reshaped by volcanic forces might offer valuable insights into planetary evolution, yet the risks involved could make studying such a place feel more like a desperate attempt to survive than a scientific expedition. The possibility of uncovering new geological features shaped by these eruptions could offer fascinating clues about the planet's past, but the constant threat of danger would make any mission a perilous endeavor. As scientists delve into the study of worlds like GJ-132b, they often grapple with the larger question of whether a planet with such violent volcanic activity could still support life. The balance between geothermal activity and habitability is one that researchers continue to explore. For GJ-132b, its fiery landscape offers a tantalizing glimpse into the evolutionary history of the universe, but it also forces us to confront the limits of what humanity might endure in its search for knowledge. This planet represents a crossroads between the beauty of discovery and the harsh reality of survival, challenging our notions of what is possible in the realm of space exploration. Meanwhile, the rotation of a planet can drastically alter the experience of human visitors. On a world with a slow rotation, a single day could stretch into weeks or even months. This would create extended periods of light followed by long, unyielding nights. Such prolonged exposure to either sunlight or darkness could have a profound effect on human circadian rhythms, leading to disrupted sleep patterns and overall health concerns. Conversely, planets with rapid rotations could have days that are shockingly brief. A swift rotation would cause the sun to race across the sky, creating a sense of urgency as each day passes in what seems like mere hours. This could lead to disorientation and psychological stress as humans attempt to adapt to such a fast-paced environment. In either case, the peculiar rotation of a planet would significantly impact the lives of its human visitors. Whether facing long days of daylight or short, intense bursts of activity, the psychological and physical toll of adapting to such extreme conditions would pose unique challenges. Each planet, with its own unique features and potential hazards, forces humanity to confront the limits of its adaptability and endurance. As we look toward the future of space exploration, we must prepare for environments that test not only our technology, but also our ability to survive in worlds vastly different from our own. The axial tilt of a planet is one of the most influential factors that could significantly impact human exploration, especially when the tilt is extreme. A dramatic tilt would result in intense seasonal changes, causing the climate to fluctuate unpredictably within a relatively short time frame. For human visitors, this means constant adaptation to rapidly shifting temperatures and weather patterns. The extreme conditions could affect everything from daily routines to the very technologies required to survive. As the climate swings wildly, the type of habitats needed could change, as could the life support systems and equipment that astronauts rely on. This means that explorers could face not only the challenge of enduring harsh conditions, but also the complex task of constantly adjusting to an environment in constant flux. Additionally, the rotational characteristics of a planet play a crucial role in the physical demands placed on any potential explorers. A planet spinning at high velocities could create a situation where gravity at the equator is weaker than on Earth. This reduced gravity would impact basic human functions, movement, strength, and even the cardiovascular system. Astronauts would have to adapt physically, learning to navigate a world where their bodies don't behave as they would in Earth's gravity. While this lighter gravity might offer some intriguing opportunities for exploration, it would also present significant hurdles. The challenge would not only be the discomfort of altered bodily functions, but the very nature of human interaction with the environment could be entirely different, making it both an alluring and complex place to visit. One planet where such conditions could come into play is HD 2D9458c, an exoplanet located about 53 light-years from Earth. This planet is particularly concerning for the prospect of human exploration due to its proximity to a parent star, which creates an incredibly hostile environment. The extreme heat generated by this closeness causes the atmosphere of HD 2D9458c to remain in a constant turbulent state, completely gaseous and in motion. This chaotic, ever-shifting atmosphere makes it nearly impossible for conventional spacecraft or habitats to remain intact without being subjected to immense stress. The planet's harshness has earned it the nickname Osiris, and it certainly lives up to the moniker. Radiation levels on HD 29458c are extremely high, mainly because of the planet's position near its star. This constant barrage of radiation presents a grave concern for the health of astronauts. Long-term exposure could lead to an increased risk of various forms of cancer and radiation-induced illnesses. At first, the effects may not be immediately apparent, but the potential damage occurring at the cellular level could be devastating. This environmental hazard presents a huge challenge for future space missions, as the technology required to shield astronauts from this radiation is still far from being able to withstand such intense exposure. Coupled with the radiation are the extreme winds that batter the surface of HD 29458c. These winds can reach speeds of several hundred miles per hour, creating another insurmountable obstacle for human exploration. The high velocity of the winds would not only endanger astronauts on the surface, but also threaten the integrity of their equipment. Spacecraft would need to be engineered with exceptional durability to survive such extreme conditions. Outdoor exposure would become virtually impossible, and even entering or exiting habitats would become a complex logistical challenge. The psychological impact on astronauts cannot be underestimated either. The constant threat posed by radiation, coupled with the brutal atmospheric conditions and the extreme technical demands of such a mission, could induce feelings of dread and anxiety. The isolation, danger, and physical toll on the human body would create an immense psychological strain. As we push the limits of space exploration, it becomes crucial to fully understand the risks involved with visiting planets like HD 209-458c. Only through careful planning, innovative technology, and a deep understanding of the environmental hazards can future missions be successful. Temperature extremes present another set of obstacles in the vast expanse of space, making them a major challenge for human missions. Venus, for example, reaches average temperatures of around 450 degrees Celsius, 842 degrees Fahrenheit, which is far beyond what the human body can endure. Not only would this heat pose a significant threat to the survival of astronauts, but it could also cause severe damage to spacecraft and technology. Life support systems, electronics, and other essential equipment would likely fail under such extreme conditions, further complicating any exploration attempts. This level of heat is so intense that it challenges our fundamental understanding of material science. Everything from construction to energy management would need to be re-engineered to withstand these conditions. In stark contrast, Mars presents a different but equally daunting challenge. With an average surface temperature of about minus 68 degrees Celsius, 90 degrees Fahrenheit, Mars poses extreme cold that could cripple even the most advanced technology. In such temperatures, everything from power systems to scientific instruments risks failure, and human habitats would need to be protected by highly advanced insulation and heating systems. The strain placed on technology in these frigid environments demands exceptional innovation and careful design to ensure functionality. It's not just the physical equipment at stake. Human health would be deeply affected by these temperature extremes as well. Beyond physical challenges, the psychological toll on astronauts dealing with extreme temperatures can't be overlooked. The mental strain of isolation, combined with the discomfort of life in such hostile environments, could significantly impact mission success. Prolonged exposure to these conditions could result in stress, fatigue, and even depression. This could severely hinder teamwork and motivation, crucial factors in ensuring the health and productivity of a crew in space. Therefore, mission planners must anticipate not only the technical hurdles posed by these extreme temperatures, but also the psychological demands placed on the individuals tasked with exploring them. In terms of preparation, these extreme conditions demand comprehensive research and extensive testing. Scientists and engineers must work tirelessly to develop new materials, structures, and life support systems capable of operating in environments that test the limits of human endurance. The technologies designed to combat extreme temperatures will be the bedrock on which future missions are built. And as humanity seeks to overcome these environmental obstacles, we inch closer to unraveling the mysteries of the universe. One exoplanet that has drawn attention for its extreme conditions is WASP-104b, a gas giant located about 500 light-years away in the constellation Leo. Classified as a hot Jupiter, WASP-104b orbits very close to its parent star, causing its atmosphere to reach searing temperatures often exceeding 1,000 degrees Celsius, 1,832 degrees Fahrenheit. These temperatures create an environment where human exploration is, at this stage, inconceivable. No existing spacecraft or technology could withstand such intense heat. Current materials used in space exploration would be overwhelmed by the heat, rendering any human mission impossible unless breakthrough technological advancements are made. The extreme temperatures on WASP-104b not only make survival difficult, they pose an existential challenge to the future of space exploration itself. The search for materials capable of resisting these temperatures would become one of the critical elements in overcoming the seemingly insurmountable obstacles presented by such hostile planets. The quest for innovation in this area is one of humanity's most exciting yet daunting challenges, as it will determine how far we can go in our exploration of distant worlds. Without advancements in heat resistance, planets like WASP-104b will remain unreachable, locked in the furnace-like embrace of their stars, forever out of humanity's reach. The exoplanet WASP-104b has become the subject of intense study, primarily due to its thick and toxic atmosphere. Composed largely of hydrogen and helium, with the potential presence of other compounds, including water vapor, this dense atmosphere generates pressures far exceeding those found in Earth's deepest oceans. For human explorers, this creates severe complications. Such extreme atmospheric pressure could lead to catastrophic structural failures in spacecraft, jeopardizing life support systems and greatly increasing the risk of fatal accidents for any crew attempting to land or study the planet. Alongside this, fierce storms are expected to rage within the turbulent air, with wind speeds that could reach several thousand kilometers per hour. These violent weather patterns not only make landing incredibly difficult, but also present significant hazards during any ascent from the surface. The combination of unrelenting heat, enormous pressure, and hazardous weather forms a formidable challenge that casts doubt on the feasibility of human exploration of distant planets. The risks escalate exponentially when contemplating human exploration of planets in close proximity to their host stars. The primary threat here is the intense radiation emitted by these stars. Proximity to a star subjects a planet to higher levels of ultraviolet radiation and frequent solar flares. This would put any human explorers at grave risk, with potential outcomes ranging from severe radiation sickness to increased rates of cancer following prolonged exposure. Advanced shielding technologies would be critical, and any surface habitats would require significant protective measures to ensure the safety of any visitors. Extreme temperatures also pose a challenge. Planets located near their stars often experience extreme temperature gradients, intense heat on the star-facing side and freezing cold on the opposite side. This stark difference makes it difficult to create sustainable living conditions. Advanced thermal control technologies would be required to maintain a stable environment for human biology, which depends on a relatively moderate and consistent temperature. The gravitational pull of the star may also limit the planet's ability to retain a thick atmosphere, leaving the surface vulnerable to cosmic and stellar radiation. A thin atmosphere could also restrict the availability of breathable air, further complicating the task of sustaining life on these planets. The combination of radiation, temperature extremes, and atmospheric instability makes visiting planets in close orbit to their stars a highly complex and perilous venture, requiring innovative technologies and thorough planning to mitigate the risks. Gliese 357b, located about 41 light-years away, presents a whole new set of challenges for potential explorers. The planet's gravitational pull is roughly 2.5 times that of Earth, meaning any explorers, whether human or robotic, would face immense physical strain. This added stress could make mobility challenging, heightening the risks of injury. Gliese 357b resides within its star's habitable zone, which suggests that surface temperatures might be suitable for liquid water. However, this warmth does not translate to a hospitable environment. The planet's atmosphere is believed to be thick and possibly rich in carbon dioxide and other harmful gases, making the risk of suffocation a major concern for explorers who lack proper life support systems. Geologic activity is another major threat to exploration. Evidence suggests that Gliese 357b may be volcanically active, with the potential for eruptions and the emission of toxic gases. These dangers could impede any attempts to land or explore the surface, with ash clouds and lava flows potentially endangering both human explorers and their equipment. On top of all this, the lack of a protective magnetic field means the planet is subject to intense cosmic and stellar radiation, further compounding the risks. The absence of this natural shield exposes explorers to the dangers of radiation sickness, making it clear that any mission to this planet would require significant technological advances and comprehensive safety protocols to address these multifaceted threats. The thick clouds shrouding Gliese 357b add yet another layer of difficulty for any astronauts attempting to navigate its atmosphere. The low visibility resulting from the dense cloud cover could create an unnerving and disorienting experience, making it difficult to judge altitude and direction. In an environment where clear sightlines are limited, astronauts would rely heavily on their onboard instruments to provide situational awareness. However, the inability to see beyond their immediate surroundings would increase the likelihood of errors, particularly when it comes to avoiding unknown atmospheric phenomena. Worse still, these clouds may conceal hazardous gases, adding an additional layer of danger that could go undetected until it's too late. The psychological impact of navigating such a harsh and unpredictable environment cannot be ignored. The constant sense of confinement and isolation would likely increase stress levels among the crew. The vast, empty expanse of space is often admired for its beauty, but when trapped in the suffocating mist of an alien world, that awe is replaced by a growing sense of vulnerability. Reliance on technology, while necessary, could only add to the astronauts' sense of disconnection from their surroundings, leading to feelings of unease and even fear. WASP-76b, a gas giant located approximately 400 light-years away in the constellation Pegasus, presents an entirely different set of extreme conditions. With temperatures soaring to a staggering 2,800 degrees Celsius on its day side, the planet offers a glimpse into a truly inhospitable environment. At these temperatures, metals such as iron vaporize and ascend into the atmosphere, creating a surreal and hostile environment. As night falls, the planet's temperature gradient between the scorching day side and the cooler night side generates fierce winds that can reach speeds of thousands of kilometers per hour. These winds carry the vaporized iron across the planet's surface, where it condenses into liquid droplets. The result is a terrifying phenomenon, iron rain falling in torrents from the sky like molten metal. This extreme and horrifying weather pattern paints a bleak picture for any explorers considering a journey to this distant exoplanet. The planet's atmosphere, characterized by such volatile and unpredictable conditions, would make any attempt at exploration or landing an incredibly dangerous and potentially fatal endeavor. The atmosphere of distant worlds holds mysteries that defy the limits of our current understanding. On planets like WASP-76b, a fascinating but unforgiving exoplanet, located more than 600 light-years away in the constellation Pisces, the environment is defined by extremes. Scientists studying this world are confronted by a planetary atmosphere that is teeming with exotic compounds, some of which have never been encountered before. Researchers suggest the presence of heavy metals, exotic molecules, and other unusual substances, all of which contribute to the intense and hostile conditions on the planet. The atmosphere's unpredictability is compounded by extreme winds, blistering heat, and frigid nighttime temperatures, all of which churn into a chaotic weather system that far surpasses anything we experience on Earth. WASP-76b's environment is a continuous cycle of heat, vaporization, and precipitation. During the day, temperatures rise to over 2,500 degrees Celsius, hot enough to vaporize metals like iron. These searing temperatures create an atmosphere where chemical reactions take place that we can barely imagine. Iron vapor and other elements react in ways that shatter our expectations, presenting challenges for scientists trying to make accurate observations. The sheer heat distorts data collected by telescopes, making it difficult for astronomers to get reliable signals. The temperatures are so intense that thermal noise often drowns out important information, causing frustration for researchers who are eager to better understand the planet's mysteries. At night, when the planet cools off, the conditions change drastically. The drop in temperature brings a whole new set of challenges and opportunities for study. The sharp contrast between daytime heat and nighttime coolness gives rise to rapid shifts in weather and atmospheric behavior. This constant fluctuation complicates the efforts of scientists who attempt to map the planet's weather patterns and chemical composition. Cloud formations may change on a whim, and the varying temperatures can lead to sudden, unpredictable weather events. The planet's unique atmospheric conditions demand advanced technology and cutting-edge techniques to study it, with both ground-based and space-based observatories working together to capture the full complexity of WASP-76b. Despite the immense difficulties, the promise of new discoveries pushes astronomers to persevere, offering humanity deeper insights into the nature of exoplanets, planets, and the vast diversity of planetary environments across the universe. Then there's GJ3512b, a different kind of enigma located in the constellation Eridanus. This exoplanet is intriguing because of its erratic and unpredictable orbital behavior, a feature that makes it difficult to study in any traditional sense. GJ3512b orbits a star that is much cooler and dimmer than our Sun, and its orbit is anything but stable. The planet follows an unusual path, one that doesn't follow the neat, predictable elliptical motion we're accustomed to observing in our own solar system. This erratic orbital behavior creates a dynamic climate on the planet that is continually shifting. Temperatures rise and fall unpredictably, causing rapid changes in pressure and atmosphere composition. Such fluctuations make it nearly impossible to predict the planet's climate patterns or to understand how the atmosphere might evolve over time. As the planet orbits its star in a wild looping path, these changes in position affect not only the weather, but also the composition of the atmosphere. GJ3512b is subject to extreme heating and cooling phases, which could cause it to lose significant amounts of gases vital to maintaining a stable atmosphere. The gravitational interactions with nearby celestial bodies only add to the planet's instability, creating a cycle that can lead to atmospheric depletion or the emergence of hazardous, life-prohibiting conditions. The dynamic orbital mechanics of GJ3512b raise significant concerns about its habitability. Could life ever take root on such a volatile world? Or is this planet too unpredictable for the kind of stability required to support living organisms? These questions are not only fascinating, they are a critical part of the ongoing search for life beyond Earth. The study of GJ3512b opens a window into a broader understanding of how planetary atmospheres react to constant turbulence and instability. Scientists studying this planet hope that by observing how its atmosphere behaves under such extreme conditions, they can gain valuable insights into the atmospheric dynamics of other planets, both near and far. This research is essential not just for the study of this one distant world, but for the future of exoplanetary science. As we expand our understanding of planets like GJ3512b, we gain a greater appreciation for the complexities of atmospheres across the universe, learning how they respond to challenges that are alien to our experience. On another level, the study of planetary atmospheres also involves understanding the risks that explorers face when venturing into such extreme environments. The density of a planet's atmosphere plays a crucial role in determining the safety of human missions to distant worlds. Planets with particularly dense atmospheres present unique challenges for astronauts and spacecraft, as the higher the density of gases, the greater the atmospheric pressure. In such environments, explorers must be prepared for extreme pressure variations that could wreak havoc on human physiology. In higher pressure atmospheres, the risk of decompression sickness increases dramatically. This condition, which can occur when astronauts transition from high pressure environments to lower pressure ones, presents a serious threat to human health. Such dangers remind us that while space exploration promises extraordinary discoveries, it also demands rigorous preparation and an understanding of the challenges posed by the diverse environments of distant planets. The exploration of exoplanets like WASP-76b and GJ3512b forces us to rethink our ideas about the nature of habitability. These worlds, while inhospitable to life as we know it, challenge our assumptions about the limits of existence and the resilience of planetary environments. They remind us that in the vastness of the cosmos, life might not always take the forms we expect, and the conditions that define a planet's potential for habitability could be radically different from anything we are familiar with. The more we learn, the more we realize that the universe is filled with both unimaginable wonders and unimaginable horrors, both of which invite further exploration and curiosity. As our technology advances and as our methods for studying exoplanets evolve, the possibility of discovering new worlds that are both alien and familiar grows ever closer, opening up endless possibilities for future discoveries. The dense atmosphere of certain planets can be a perilous environment for human life. These atmospheres may contain a range of chemical compounds that are not only harmful but potentially toxic. Some planets possess atmospheres rich in gases like ammonia or methane, substances that pose serious respiratory risks to humans and are highly flammable when in contact with oxygen. These hazardous conditions require explorers to employ advanced safety protocols with specialized equipment designed to filter or neutralize these dangerous substances before any human can venture further. Life support systems, in particular, must be meticulously designed to endure such hostile environments, ensuring that they are capable of sustaining human life in the most extreme conditions. Visibility is another crucial factor that can be severely impacted by the thickness of an atmosphere. On planets where the air is dense with particulate matter or opaque gases, explorers could easily become disoriented or lost. In these cases, navigating through the planet's surface becomes a complex challenge. The need for advanced technology that compensates for poor visibility becomes paramount, allowing explorers to gather real-time data and navigate safely despite the murky surroundings. Explorations of such foreign worlds must be thoroughly planned, not only with regard to the safety measures that are in place, but also with respect to the unpredictable nature of a planet's gaseous composition. The vehicles and structures designed for such missions must be engineered to withstand vast differences in pressure, and in some cases, even to maintain buoyancy within dense atmospheres. This ongoing research and development is crucial to ensuring that habitats and transportation systems can endure the extreme conditions of some of the most distant worlds in the universe. A prime example of such a world is WASP 107b. Located approximately 20 million light-years from Earth, this peculiar exoplanet raises serious concerns about the feasibility of human visitation. WASP 107b, classified as a hot Neptune, boasts a gas-heavy atmosphere dominated by hydrogen and helium, with traces of other elements and compounds. The low density of this atmosphere suggests that the planet could be covered by thick, unbreathable gases and a shallow layer of heavy elements. For any human to survive there, it would require extreme adaptations to handle the potentially toxic atmosphere and extreme temperatures, often reaching levels that could be fatal to human biology. In addition to the climate challenges, WASP 107b also presents a significant barrier to landing due to the absence of a solid surface. Approaching the planet would be like traversing an ocean of gas, where landing becomes impossible. Any human mission would require equipment that could withstand intense pressures and turbulent weather conditions, which would significantly increase the complexity and risks of the mission. The exploration of such a world serves as a stark reminder of the enormous challenges that gas giants present to human exploration. The hazards of space travel are not limited to atmospheric conditions alone. Radiation exposure presents an equally dangerous challenge, especially when astronauts venture beyond Earth's protective atmosphere. Unlike Earth, which is shielded from harmful cosmic rays and solar radiation by its magnetic field and atmosphere, other celestial bodies offer little to no protection. As a result, astronauts are at constant risk of radiation exposure, which can lead to immediate effects such as nausea, vomiting, and skin burns, as well as long-term consequences like an increased risk of cancer and cognitive decline. Even moderate levels of radiation over extended periods can impact immune function, making astronauts more susceptible to infections and other illnesses. In extreme cases, radiation exposure can alter vision and impair decision-making abilities, compromising mission success. As such, space agencies must develop effective shielding technologies to protect astronauts, particularly during solar flares when radiation levels can spike to dangerous levels. Carefully timed spacewalks, specialized habitats, and protective gear are just some of the strategies employed to mitigate the effects of radiation and ensure astronauts' safety as they explore new frontiers. An even more extraordinary challenge to human exploration can be found on exoplanet Kelt 12b. This hot Jupiter, which orbits extremely close to its star, possesses an atmosphere characterized by extreme temperatures, often exceeding 1,000 degrees Celsius. The resulting heat generates powerful storms, fueled by fierce winds and a mixture of various gaseous elements, including sodium and potassium. This combination creates an atmosphere of violent chaos, with winds capable of exceeding the speed of the strongest tornadoes on Earth. The atmospheric conditions on Kelt 12b are so hostile and alien that they present unprecedented risks for any human exploration. Intense heat waves and thermal tides lead to rapid pressure shifts, which in turn generate devastating storms. These extreme atmospheric fluctuations create an ever-changing landscape, as the planet's surface constantly reshapes under the pressure of these violent forces. Any mission to Kelt 12b would require innovations in technology and engineering to ensure survival in such an unpredictable and hazardous environment. The exploration of such distant worlds highlights the unimaginable complexity of space missions, with each planet offering unique challenges and risks. Whether it is the toxic atmosphere of WASP 107b, the radiation hazards of deep space, or the tumultuous weather of Kelt 12b, every expedition requires careful consideration, advanced technology, and careful planning to ensure the safety and success of those involved. The mysteries of the cosmos may be enticing, but the risks of exploration are equally vast, demanding a commitment to scientific advancement, innovation, and an unwavering drive to push the boundaries of human knowledge and survival. The atmosphere of Kelt 12b is a complex and mysterious environment that presents new challenges and opportunities for exploration. One of the most striking features of this alien world is the presence of various compounds, including metals, in gaseous form. This unique atmospheric composition hints at the possibility of extraordinary weather phenomena, such as the formation of metal clouds. These clouds could potentially produce rain made of molten metal, a phenomenon that, while captivating, would be incredibly dangerous. The extreme temperatures and chemical reactions at play on Kelt 12b create an atmosphere that is inhospitable to life as we know it, raising questions about the survival of any hypothetical atmospheric organisms that might exist in such an extreme setting. However, scientists are not studying Kelt 12b merely to satisfy human curiosity about far-off planets. The planet offers a valuable opportunity to learn more about the evolution of exoplanetary atmospheres and the dynamics that shape them. By understanding the complex and often treacherous conditions on planets like Kelt 12b, we can glean insights into the broader field of planetary science, shedding light on the atmospheric processes that might occur elsewhere in the universe. This knowledge could significantly enrich our understanding of atmospheric dynamics on planets throughout space. Exploring planets with dense atmospheres, such as Venus, presents its own set of unique challenges that can invoke concern among scientists and engineers. These planets are often shrouded in thick clouds of gases, which trap heat and create a fierce greenhouse effect. On Venus, for instance, surface temperatures are so high that they are capable of melting lead. Such extreme conditions create considerable hurdles for any mission aiming to explore the surface or study the atmosphere. Instruments and rovers must be specially designed to withstand intense heat and pressure in order to function effectively. The crushing atmospheric pressure on planets with dense atmospheres is another critical obstacle. At the surface of Venus, the pressure is more than 90 times that of Earth's at sea level, exerting an immense force that could easily damage equipment that isn't specifically built to endure such conditions. Even the smallest malfunction in equipment can lead to disastrous outcomes, derailing entire missions. This raises significant questions about the reliability and durability of our current exploration technologies. Furthermore, the thick cloud cover on these planets distorts signals and obstructs visibility, making it incredibly difficult to establish effective communication with exploration missions on the surface. This not only hinders remote operations, but also complicates data transmission, further adding to the uncertainty of any mission. Scientists and engineers must work tirelessly to develop innovative solutions that can circumvent these challenges, which fosters an atmosphere of anxiety and concern regarding the potential loss of contact or incomplete data during critical phases of exploration. These formidable challenges only amplify the need for careful planning and cutting-edge engineering. As each new mission pushes further into these inhospitable environments, there is an ever-present fear that our existing technology may not be advanced enough to gather all the information hidden beneath the dense clouds. Yet, it is this very fear that fuels the relentless pursuit of knowledge. The desire to explore and understand these distant worlds remains a powerful force, propelling humanity forward in the quest for discovery. Gravitational conditions on other celestial bodies also introduce new and often unexpected challenges for explorers venturing beyond Earth. The force of gravity affects every aspect of movement and physical well-being. On a planet with a weaker gravitational pull, like Mars, explorers might find themselves leaping much farther than they would on Earth. While this might initially seem like an advantage, it increases the risk of falls and injuries as the body struggles to adapt to unfamiliar movement patterns. These altered movements can lead to quicker exhaustion, as muscles that are not typically used on Earth become engaged in ways they were not designed for. In stark contrast, planets with stronger gravitational fields, such as those found on Jupiter's moons, present their own set of complications. Explorers on such worlds would struggle to move, as the immense gravitational forces would make every step more challenging. The increased weight of equipment and life support systems would add to the logistical burden, complicating transportation and mobility. Astronauts would also face the risk of injury during landings, as the stronger gravity would amplify the physical stress on their bodies. The longer-term consequences of living in these gravitational conditions are also a matter of concern. Research indicates that astronauts who spend extended periods in microgravity suffer from muscle atrophy and bone density loss. On planets with lower gravity, explorers might face the opposite problem: overstressed muscles as they adjust to a new gravitational regime. These extreme conditions can have lasting effects on the health of astronauts, shaping the way we think about human adaptability in space exploration. The inhospitable surface of LHS 1140b, another exoplanet on our radar, presents psychological challenges that could rival the physical demands of space exploration. With an atmosphere dominated by extreme radiation levels and blistering surface temperatures, LHS 1140b is a planet far more hostile than anything we encounter on Earth. Humans exposed to such an environment would likely experience heightened levels of stress and anxiety. The fact that this exoplanet orbits much closer to its star than Earth does to the Sun means that the surface is bathed in relentless heat, making survival on this planet a daunting proposition. The contrast between human life on Earth and the unforgiving conditions of LHS 1140b could trigger feelings of profound isolation and helplessness. These extreme environments often lead to a psychological state known as environmental hyperarousal, in which individuals are in a constant state of heightened alertness. This continuous stress could impair cognitive functions, making it difficult for explorers to make quick decisions under pressure. It could also hinder collaboration among team members, as stress and anxiety lead to an erosion of effective communication. The psychological strain of such harsh conditions raises important questions about the mental resilience required for long-term human exploration of distant worlds. As we push further into space, not only must we consider the physical challenges of extreme environments, but also the emotional toll they might take on those who venture into the unknown. The pursuit of knowledge and exploration is, after all, not just about the places we discover, but also about the strength of the human spirit as it faces the vast, unforgiving cosmos. In the vast expanse of space, the psychological toll on explorers venturing into the unknown can be profound. The harsh, unforgiving environments of distant planets present not only physical challenges, but also deep emotional and mental hurdles. Consider the scenario where astronauts find themselves far from the comfort of Earth, surrounded by alien landscapes. The constant awareness of life's precariousness in such a hostile environment can lead to feelings of despair and hopelessness. The inability to seek solace in familiar activities or surroundings strips away the very essence of human experience that fosters emotional well-being. This disconnection can exacerbate pre-existing mental health conditions such as depression or anxiety, complicating the mission in ways that are difficult to anticipate. As exploration missions become longer and more remote, the human psyche will undoubtedly be tested. Being placed under constant pressure in extreme environments forces us to confront our limits, both physical and mental. This reality underscores the urgent need for mental health support and thorough preparatory training for astronauts, especially for those who may one day set foot on planets like LHS 104b. Understanding these psychological implications is essential to ensuring the success of long-term space missions. For future explorers, safeguarding both their productivity and emotional well-being will be as crucial as developing the technology needed to survive the harshest physical conditions. The discovery of exoplanets has dramatically expanded our understanding of distant worlds, with 51 Pegasi b being one of the most significant milestones. This planet, which was the first exoplanet ever detected orbiting a sun-like star, has become a symbol of the groundbreaking advancements in space exploration. Orbiting its host star at a remarkably close distance, 51 Pegasi b is exposed to scorching temperatures that can exceed 1,000 degrees, making it one of the hottest known planets. The extreme heat presents enormous challenges for any future exploration missions. Standard spacecraft materials, from structural components to electronic systems, would be unable to withstand such high temperatures. For any mission to succeed, engineers would need to develop innovative heat-resistant technologies to protect both explorers and equipment from rapid degradation or complete failure. Additionally, the tumultuous environment of 51 Pegasi b, a gas giant, poses further difficulties. The planet's extreme heat likely contributes to violent weather patterns, including powerful storms and high-speed winds. These chaotic atmospheric conditions would present safety risks not only during landing and surface exploration, but also during atmospheric sampling missions. As such, any space agency planning a mission to 51 Pegasi b would need to consider these factors carefully. One of the most pressing challenges would be the development of advanced cooling systems to combat the intense heat. These technologies would be critical for safeguarding equipment and ensuring that explorations could be conducted effectively despite the planet's extreme conditions. The unique challenges presented by 51 Pegasi b are a reminder of the broader difficulties that await humanity as we look to explore distant worlds. Even the most sophisticated technology may find itself tested beyond its limits, and the lessons learned from such missions will shape the future of space exploration. Similarly, the rotation of distant planets plays a pivotal role in shaping the environments astronauts would experience. Planets with unusual spin rates could drastically alter the conditions visitors would encounter, creating environments that are far from anything on Earth. For instance, a planet that rotates slowly would have long days and nights, resulting in extreme temperature variations. These fluctuations would pose a serious challenge to human adaptability and technology. During the day, the surface would be scorched by intense heat, and at night, temperatures could plummet into freezing cold. Such dramatic shifts in heat could have profound effects on both the explorers and their equipment, requiring them to prepare for conditions unlike anything they have experienced before. Venus, with its incredibly slow rotation, serves as a case in point. Taking roughly 243 Earth days to complete one full rotation, Venus presents an extraordinary day-night cycle. Visitors to this planet would experience an agonizingly long day followed by an equally long night, which could have significant psychological effects. Sleep patterns, circadian rhythms, and overall health could be severely impacted by such a prolonged cycle. The harsh atmosphere of Venus, dominated by carbon dioxide and clouds of sulfuric acid, would require specially designed habitats to ensure survival. For planets that rotate rapidly, like Jupiter, the environment would be no less challenging. Fast rotation rates contribute to powerful atmospheric phenomena, including the planet's iconic storm systems, such as the Great Red Spot, an enormous storm larger than Earth itself. The winds, high atmospheric pressure, and turbulent weather patterns that accompany these storms would create an environment that is both awe-inspiring and dangerous. Visitors would have the opportunity to witness some of the most striking natural spectacles in the solar system, but they would also face the harsh realities of high-velocity winds and extreme pressure. Ultimately, the rotation dynamics of these planets shape not just the environment, but the very nature of human interaction with these worlds. The unusual day-night cycles and resulting weather patterns would influence everything from exploration timelines to the design of spacesuits and habitats. Each journey into deep space is an exploration of the unknown, offering both unique challenges and inspiring opportunities. Consider the case of K2-18b, an exoplanet located approximately 135 light-years from Earth. This distant world has intrigued scientists due to its location within the habitable zone of its star, making it a prime candidate for the potential existence of life. However, K2-18b also presents significant challenges. Recent studies have revealed the presence of aromatic compounds, such as dimethyl sulfide, in its atmosphere. While such compounds are often associated with biological processes on Earth, their mere existence does not necessarily indicate the presence of life. In fact, the atmospheric composition of K2-18b raises serious questions about its ability to support life. The presence of a dense hydrogen atmosphere suggests extreme pressure conditions that could make the planet inhospitable to carbon-based life forms. Moreover, temperature fluctuations on K2-18b are expected to be severe, with the planet experiencing intense atmospheric pressure and varying climate extremes. These conditions could result in an environment that, while potentially rich in complex chemistry, might be far too hostile for life as we understand it. The delicate balance of temperature, pressure, and chemical composition necessary to support life may simply not exist on this distant world. As scientists continue to probe the mysteries of exoplanets like K28b, they are reminded of the complexity and fragility of life, both on Earth and beyond. The presence of clouds rich in methane and other gases on distant planets like K2218b could make it difficult to observe the surface, posing significant challenges to any potential life forms that might exist there. These thick, obscuring clouds would likely prevent any energy from reaching the planet's surface from its star, effectively stifling photosynthesis, an essential process for life as we know it on Earth. As scientists continue to probe the mysteries of this exoplanet, these atmospheric traits remind us that even in the so-called habitable zones, the environmental conditions on other planets can be far more complex and daunting than we might expect. The discovery of microbial life, potentially existing in far-flung worlds like K218b, introduces exciting prospects for scientific discovery. But with such prospects come risks that cannot be overlooked. If life forms indeed exist in such alien environments, they may harbor biochemistries vastly different from anything we recognize here on Earth. This unfamiliarity creates significant concerns, not only due to the unknown nature of such life forms, but also because they could present unforeseen dangers to human explorers. Microbial life on K218b could have evolved to possess properties that elude the human immune system entirely. This makes them potential threats to human health, as these microorganisms might cause reactions ranging from minor allergic responses to more severe, unpredictable infections that our current medical knowledge cannot address. The possibility of encountering these novel pathogens represents a formidable challenge, as human explorers, even those equipped with the most advanced medical technology, could still find themselves powerless against such alien threats. The evolution of microbial resistance could also complicate matters, introducing an additional layer of risk for space missions. But the challenges don't end there. Even if these microbes are harmless, their presence could still interfere with human technology. Life support systems, critical for the survival of astronauts, could malfunction if these microorganisms interact with them in ways we don't yet understand. Similarly, contamination of food or water supplies by microbial life could lead to biocontamination, making it essential for explorers to take extraordinary precautions. This underscores the importance of conducting thorough research and preparing contingencies before any attempts are made to interact with alien microbial life on planets like K2 to 18b. For such a mission to succeed, protocols must be stringent, protective gear must be foolproof, and containment measures must be rigorous. These safeguards would help ensure the safety of both the human explorers and the integrity of the alien ecosystem they aim to study. The excitement of exploration cannot blind us to our responsibility. We must tread lightly, ensuring that we don't inadvertently unleash unknown dangers or disrupt a fragile foreign environment. Looking beyond K218b, we find other fascinating exoplanets, such as TOI 700d, located within a habitable zone that raises intriguing questions about the possibility of life beyond our solar system. But there's an additional, potentially hazardous factor to consider: the presence of dark matter in the vicinity of TOI 700d. Dark matter, though invisible and undetectable by conventional means, makes up a substantial portion of the universe's mass. It interacts gravitationally, yet it emits no light or energy that can be measured. While its presence is widely accepted in theoretical models, the potential impact of dark matter on space exploration is still poorly understood. One significant concern for explorers heading to TOI 700d would be the unpredictable effects dark matter might have on gravitational forces. If dark matter is unevenly distributed in the region, it could create gravitational anomalies that affect spacecraft trajectories, potentially leading to navigational problems or making landing procedures more hazardous. Such anomalies could also introduce unanticipated challenges to orbital dynamics, complicating mission planning and safety. Moreover, dark matter's interactions with regular matter could result in environmental changes that are equally difficult to predict. If it influences atmospheric conditions or geological stability on TOI 700d, explorers could face severe weather patterns, seismic activity, or even volcanic eruptions caused by these unknown forces. The unpredictability of dark matter makes it a formidable unknown in the exploration of distant worlds. While it might not pose direct threats like radiation or extreme climate conditions, the enigmatic nature of dark matter could lead to complications that scientists and explorers alike must be prepared for. Understanding how dark matter might affect exoplanets will be key to developing strategies for exploring such distant worlds. The more we learn, the better equipped we will be to face these challenges and mitigate any risks they pose to human safety. Closer to home, on Earth, geological phenomena like earthquakes, volcanic eruptions, and landslides are constant reminders of nature's immense power and unpredictability. Earthquakes, for example, occur when there's a sudden release of energy in the Earth's crust, causing the ground to shake violently. Depending on their magnitude, these events can result in catastrophic damage to infrastructure, cause loss of life, and displace entire communities. The Richter scale, which measures the magnitude of earthquakes, shows that even moderately powerful quakes can have devastating effects, particularly in densely populated urban areas. Volcanic eruptions present another formidable natural hazard. These eruptions, which can occur without warning, can release a variety of destructive materials, including lava flows, pyroclastic flows, ash clouds, and toxic gases. These eruptions pose immediate threats to nearby communities and can have long-lasting consequences, as seen in the 1980 eruption of Mount St. Helens. This event dramatically reshaped the landscape and led to significant disruptions in air quality and climate patterns. Communities downwind of volcanic eruptions are often left to contend not only with the immediate dangers of ash fallout, but also with the long-term effects, such as damage to agriculture and water supplies. Landslides, another geological hazard, often occur in areas with steep terrain or unstable ground. Triggered by heavy rainfall, seismic activity, or human interference, these massive shifts in earth and rock can bury homes, block roads, and isolate entire communities. The impacts of landslides can be particularly devastating in mountainous regions or places where the land has already been destabilized due to construction or other activities. These events often result in the loss of life and significant disruption to daily life, making them a pressing concern for affected communities. While scientists and governments work tirelessly to improve prediction techniques and enforce better construction standards, these natural events remain unpredictable. Awareness, preparedness, and response strategies are essential in minimizing their impact. By being proactive, communities can better protect themselves when nature reveals its unpredictable and often destructive side. Finally, as human explorers venture farther into space, psychological challenges also loom large. The isolation and distance from Earth that come with missions to distant star systems like BD plus 20 degrees 3007 can profoundly affect an explorer's mental well-being. Without the regular comforts and social interactions of life on Earth, explorers may experience intense feelings of loneliness, anxiety, and a deep sense of disconnection from familiar human experiences. The vastness of space can also prompt existential reflection, making explorers acutely aware of their own vulnerability and the seemingly infinite expanse around them. Space adaptation syndrome is a term used to describe the psychological stress that astronauts may face when exposed to the unfamiliar conditions of deep space. This syndrome can affect mood, cognition, and overall well-being, adding another layer of complexity to human space exploration. The mental challenges of such isolation are compounded by the knowledge that explorers are venturing into a realm where even the smallest misstep could have catastrophic consequences. How they cope with these challenges could determine not just the success of their missions, but also their survival in an environment where human resilience is pushed to its limits. The challenges of space exploration extend far beyond the technical aspects of travel and discovery. The psychological toll, exacerbated by the vast physical distance from Earth, can be overwhelming. Imagine being in a spacecraft, thousands, perhaps millions of miles from home, knowing that help is not just a phone call away, but light years away. This awareness creates an inherent sense of vulnerability, amplifying every mental strain. Any mental deterioration that arises becomes more pronounced in these extreme environments, with no immediate assistance or comforting voice from loved ones to offer reassurance. Those selected for missions to distant planets or moons are not only required to possess exceptional technical skills, but also extraordinary emotional resilience. Extended isolation in space tests the human psyche in ways that are difficult to replicate on Earth. However, despite these profound challenges, there is a flip side. In this intense isolation, explorers can forge deeper, more meaningful connections with their fellow crew members. The shared experience of facing the unknown together can foster a sense of camaraderie and teamwork that strengthens bonds and promotes psychological resilience. Furthermore, the extreme conditions of space can spark creativity, pushing explorers to think outside the box and make breakthroughs that may not have been possible in a more comfortable setting. The need to adapt quickly to unforeseen challenges often leads to innovative solutions. Thus, the exploration of distant worlds like BD plus 20-307 is not only a scientific and technological pursuit, but a deeply personal one as well. It reshapes explorers' understanding of the universe and of themselves. Earth's most extreme environments provide an earthly glimpse into the mental and physical tolls faced by space explorers. Take, for instance, the polar ice caps, where temperatures can plunge below freezing and survival becomes a constant battle against the elements. In these frigid extremes, frostbite and hypothermia are real threats, but the psychological challenges are just as severe. Isolation, coupled with unrelenting weather, can erode one's mental state, creating a sense of helplessness and loneliness. As climate change alters these delicate ecosystems, the unpredictability of weather only exacerbates these stresses, forcing those who live in these regions to constantly adapt to rapidly changing conditions. Similarly, deserts offer their own set of challenges. Temperatures can soar above 100 degrees Fahrenheit during the day and plummet to freezing at night. The scarcity of water and vegetation makes survival a daily struggle. Dehydration, which can quickly become life-threatening, is a constant concern. Without access to fresh water, health deteriorates rapidly, and the lack of resources can even spark conflict between neighboring communities. These harsh conditions, both physically taxing and mentally draining, require individuals to push beyond their limits, often with little to no hope for immediate relief. At high altitudes, the body faces yet another challenge. As the atmosphere thins, the risk of altitude sickness increases, and the human body must work harder to obtain oxygen. These conditions can lead to life-threatening situations if not managed carefully. Coupled with bitter winds and frigid temperatures, the dangers of high-altitude exploration create a test of endurance, both physically and psychologically. The challenge is further compounded by the unpredictable nature of natural disasters, such as earthquakes, volcanic eruptions, and floods. These disasters can destroy infrastructure, leaving entire communities vulnerable and ill-prepared for the chaos that follows. The resilience needed to adapt to such conditions leaves lasting psychological effects, as individuals are forced to contend not only with immediate dangers, but also the uncertainty of future challenges. Space travel introduces an entirely new realm of risks, many of which stem from the intense atmospheric pressures astronauts face. Unlike Earth's atmosphere, which provides a degree of protection, space is a vast, unforgiving vacuum. The launch and re-entry phases of space travel subject astronauts to forces far greater than what they experience on Earth. The sheer velocity of a spacecraft hurtling through the atmosphere can create a profound sense of vulnerability and fear. Astronauts must confront the reality of being in a sealed metal capsule, zooming through space at extraordinary speeds, knowing that even the smallest malfunction could have catastrophic consequences. The thought of being exposed to pressures that could potentially crush the body or cause oxygen deprivation is a constant source of anxiety. Despite years of rigorous training, this fundamental fear of the unknown is hard to shake. On top of the physical strain, astronauts face an additional mental burden: profound isolation. In the confined space of a spacecraft where mobility is limited and social interaction is sparse, the psychological effects can be magnified. Anxiety and stress can mount, particularly when astronauts are expected to maintain peak performance under immense pressure. The knowledge that their well-being, as well as the safety of their crew members, rests in their hands can add a layer of psychological weight that is difficult to bear. Even the most seasoned astronauts are not immune to the intense mental strain that comes with the territory. Despite all the preparations, the reality of space travel is fraught with risks, many of which tap into our deepest fears of the unknown. The combination of extreme atmospheric pressures and psychological challenges creates a complex terrain that only the most resilient individuals can navigate. When considering the potential for exploring distant planets, the vastness of space presents even more complications. Take K2-141b, a super-Earth located more than 200 light-years away from Earth. The conditions on this exoplanet are harsh and inhospitable, making any potential human exploration both daunting and dangerous. The most immediate obstacle is the communication delay. Signals traveling at the speed of light would take over 200 years to reach Earth from K2-141b, creating a significant disconnect between explorers and mission control. In a high-risk environment like K2-141b, where temperatures can reach extreme highs and the atmosphere is unsuitable for human life, timely communication becomes a matter of life or death. In an emergency, the inability to receive immediate guidance or assistance could drastically reduce the chances of survival. In such a situation, every second counts. Waiting decades for help in the event of a crisis could have devastating consequences. The combination of physical, psychological, and environmental challenges faced by those venturing into the unknown, whether on Earth or in space, underscores the resilience required to undertake such monumental journeys. Both exploration and survival demand a strength that goes far beyond physical endurance. It requires the capacity to adapt to the most extreme conditions and the courage to face the deepest uncertainties. The challenges of communication in extreme environments are compounded by the harsh realities of the locations themselves. The distant exoplanet K2-41b offers a chilling example of how conditions can go from manageable to life-threatening in an instant. Extreme temperatures and the ever-present risk of volcanic activity paint a picture of an environment that is both volatile and unforgiving. These ever-shifting dangers require decisions to be made on the fly, with no room for delay. In such a place, even the smallest miscommunication or a single second lost can be the difference between survival and catastrophe. The nature of K2-41b's unpredictable environment underscores the growing need for autonomous systems that can operate independently, capable of adapting to situations far beyond human control. As we continue to push the boundaries of exploration beyond our own world, the question arises, how do we prepare for expeditions to such hostile territories where every second without support could endanger human lives? This need for rapid response and instant decision-making isn't unique to K2-41b. The challenges of communication are echoed across other distant worlds as well. WASP-43b, an exoplanet located approximately 39 light-years from Earth, offers another striking example. This planet, classified as a hot Jupiter, orbits very close to its parent star, resulting in surface temperatures that can soar above 1,000 degrees Celsius. The combination of extreme heat and atmospheric pressure fosters an environment conducive to violent electrical activity. The resulting storms are unlike any weather systems found on Earth, with lightning that is not only spectacular to observe, but also potentially deadly to spacecraft attempting to study it. The severity of these electrical phenomena is magnified by the planet's volatile atmospheric conditions, which generate powerful storms capable of releasing enormous amounts of energy. Lightning discharges of such magnitude pose a significant threat to the integrity of any equipment sent to explore WASP-43b, potentially damaging sensitive instruments and disrupting communications. But the danger does not stop there. The planet's atmosphere is rich in a variety of compounds, including sodium, potassium, and water vapor, all of which contribute to complex chemical and electrical interactions that can create unpredictable weather patterns. This makes it nearly impossible to predict safe windows for landing or even for conducting research. In the face of these challenges, any mission to WASP-43b would require advanced technology designed to withstand not only the extreme temperatures, but also the violent electrical storms that rage across its atmosphere. Exploration missions would need spacecraft and instruments capable of enduring lightning strikes and electromagnetic disturbances, ensuring reliable performance under conditions that would quickly overwhelm more conventional equipment. Such missions represent a significant engineering challenge. It is not simply the extremes of temperature and electrical activity that pose a threat. It is the sheer unpredictability of the environment itself. As scientists and engineers work to develop the necessary tools for exploration, they must also consider how to design systems that can survive in an atmosphere where the laws of weather and physics seem to operate on a much more violent scale than anything encountered on Earth. Meanwhile, the psychological toll of these distant missions can be just as formidable. Astronauts training for and embarking on missions to study exoplanets like WASP-43b must endure extreme stressors in environments that simulate isolation and confinement. These conditions often lead to feelings of sensory deprivation, vulnerability, and even claustrophobia, emotions that are only exacerbated when coupled with the long periods of separation from Earth. For astronauts on missions to distant worlds, the absence of normal life on Earth, compounded by the sheer distance, can foster feelings of detachment and isolation. These psychological stressors are often compared to the pressures faced by individuals living in isolated underwater habitats or working in remote stations in the Arctic, where the environment itself exacerbates any interpersonal conflicts or stresses. The combination of isolation, the strain of maintaining focus under constant pressure, and the weight of knowing that help is millions of miles away can lead to severe mental health challenges. The study of exoplanets like WASP-43b is thus as much about understanding the human mind as it is about understanding the environment. As the technology to explore these far-off worlds advances, so too must our approach to astronaut training and psychological support. Developing strategies to manage stress, promoting team-building exercises, and ensuring that astronauts have a strong support system in place can make all the difference when it comes to sustaining mental health and maintaining the focus required for groundbreaking scientific work. The exploration of pulsar systems further highlights the complexity of deep space missions. PSRB 1257 plus 12b, a planet orbiting a pulsar, presents an entirely different set of challenges. Pulsars are the remnants of supernova explosions, highly magnetized rotating neutron stars that emit intense beams of radiation, including gamma rays and X-rays. For PSRB 1257 plus 12b, these radiation levels pose an enormous barrier to human exploration. The constant bombardment of high-energy particles makes the surface of the planet inhospitable to any unprotected explorers. In this environment, the health risks associated with radiation exposure are terrifyingly high. Long-term exposure to such intense radiation can lead to a host of health problems, including an increased risk of cancer, nerve damage, and other potentially life-threatening conditions. Any human mission to explore this planet would require sophisticated shielding technologies designed to protect astronauts from this relentless radiation. Without such protection, the risks to human life would be insurmountable. In the pursuit of understanding distant worlds, we are confronted with a sobering reality. While the potential for discovery is immense, so too are the risks. From extreme temperatures and unpredictable electrical storms to the overwhelming radiation emitted by pulsars, every mission into deep space is a reminder of the profound dangers that lie beyond our reach. Yet, with each challenge comes the opportunity for innovation, as scientists and engineers work tirelessly to develop the technologies that will one day allow us to explore these distant frontiers safely. As we venture into the unknown, one thing remains clear. Our understanding of the universe will continue to evolve, driven by the courageous few who dare to push the boundaries of human exploration. The challenges posed by the harsh radiation environment of distant worlds, like PSRB 1257 plus 12b, stand as a formidable barrier to any potential exploration missions. The intensity of radiation in this region is so extreme that it could dramatically limit the duration of human stays on the planet. To survive in such conditions, astronauts would need to rely on highly specialized equipment and habitats that are designed to withstand or deflect this radiation. This means that before even considering a human mission to PSRB 1157 plus 12b, technological advancements would need to progress significantly. Only through cutting-edge innovation could we begin to imagine a safe journey to such a distant and hostile world. As we contemplate the prospects of exploring far-off planets, PSRB 1257 plus 12b stands as a sobering reminder of the challenges awaiting us beyond the familiar reaches of our solar system. The lessons we learn from studying this pulsar and its planetary system contribute immensely to our understanding of cosmic hazards. In doing so, they help to pave the way for safer, more sustainable exploration of the universe. A universe that is not only vast, but filled with dangers that we have yet to fully comprehend. One of the most striking and dangerous geological features of this planet is the presence of supervolcanoes. These colossal volcanic systems are capable of erupting with a fury that is almost beyond imagination. When such a volcano erupts, it can release immense quantities of ash, gas, and lava into the atmosphere. The impact of these eruptions is not limited to the immediate vicinity. It can trigger global climate shifts, disrupt ecosystems, and change weather patterns for years. These eruptions can be far more massive than anything we have witnessed on Earth, reshaping the planet's surface and affecting the climate on a planetary scale. In addition to the threat of supervolcanoes, PSRB 1257 plus 12b also experiences extreme tectonic activity. The movement of tectonic plates is a constant, leading to frequent and powerful earthquakes that can reshape the landscape almost instantaneously. Such seismic activity suggests that the planet's interior remains highly active, possibly driven by the heat of a molten core. This constant shifting of the planet's crust creates an environment that is hostile to any form of life or human endeavor. The landscape itself is in a state of constant change, where landslides and mud flows occur regularly, further complicating any efforts to explore or settle the surface. The constant seismic activity and rapid erosion mean that the planet's surface is continually transforming. What might appear as a stable area one moment could be drastically altered in the next. This instability poses serious risks to anyone attempting to inhabit or explore the surface. Although there is undeniable beauty in the stark landscapes of this world, that beauty comes with the constant threat of danger. The geological instability here is a reminder of nature's overwhelming power and the fragility of life in such extreme environments. Moreover, the strange and unique features of this planet's surface suggest that its geological history has been shaped by a variety of processes that are not entirely understood. These processes may be linked to the planet's unusual atmosphere or the broader cosmic conditions in which it exists. Understanding the geological forces at play on PSRB 1057 plus 12b is crucial not only for those who may one day wish to explore the planet, but also for scientists seeking to unlock the broader mysteries of planetary geology across the universe. The history of our own planet is similarly marked by moments of darkness and upheaval that have left a deep imprint on human perception and emotion. From natural disasters like catastrophic volcanic eruptions and hurricanes to the long, cold nights of ice ages, these events have shaped our collective psyche. Humans, ever observant of nature, have learned to respond to extreme weather, not only for survival, but also as a means of understanding the world around us. In the face of unpredictable and violent weather, fear often emerges, a primal response that dates back to our ancestors who had to be attuned to the environment to ensure their survival. Extreme weather serves as a stark reminder of nature's raw power. Droughts, floods, and storms all pose threats to human survival, and this awareness of nature's unpredictability can fuel anxiety and fear. These natural forces are often beyond human control, further compounding our sense of vulnerability. Despite the advancements in technology, we remain small players in a vast, uncontrollable system, a realization that stirs deep existential fears. This fear of the unknown, of impending calamity, can trigger a longing for predictability, safety, and stability. Moreover, the darker chapters of Earth's history, the mass extinctions and environmental crises that have shaped life on this planet, continue to echo in our present-day concerns. The consequences of these ancient cataclysms serve as a backdrop for modern fears, particularly as we face the consequences of climate change. This phenomenon, a direct result of our past exploitation of the Earth's resources, is now a dominant issue on the global stage. As climate change accelerates, there is a growing sense of dread about the future. This fear is not only about the immediate impacts on our own lives, but also about the legacy we will leave behind for future generations. The growing discourse around climate change often stirs emotions that are deeply rooted in humanity's darkest historical moments. The extinction events that once wiped out vast swaths of life on Earth are mirrored by our current environmental challenges. In this context, natural disasters are not only reminders of our vulnerability, but also warnings. When catastrophic events strike, whether in the form of floods, wildfires, or heat waves, they bring old fears to the surface. Yet, they also serve as calls to action, urging society to take responsibility for the state of the planet and work towards meaningful change. These dynamics reveal how our understanding of the planet's past continues to shape the narratives we tell ourselves about the future. Our fears and anxieties about the world around us are not just reactions to present-day challenges, but also echoes of the ancient crises that have shaped the evolution of life on Earth. The interplay between these ancient fears and contemporary environmental issues is palpable in today's global conversations about climate change, as they intertwine with a deep sense of urgency about the future. The size and rapid orbit of a planet around its star have a profound impact on the environmental conditions that prevail on its surface. For instance, smaller planets tend to have weaker gravitational pulls, making it more difficult for them to retain their atmospheres. This can expose the planet's surface to extreme temperatures and harmful radiation, especially if the planet is located very close to its star. When a planet orbits its star in a short time frame, it experiences intense heating, which can lead to scorching daytime temperatures and freezing nights, particularly if the planet has a slow rotation. In some cases, if the planet's orbit is exceptionally quick, the temperature fluctuations between day and night can become even more severe, creating conditions that are far harsher than anything experienced on Earth. In these extreme environments, the planet's atmosphere, if it exists, may struggle to buffer the surface from the intense radiation and temperature swings. This can give rise to toxic winds, deadly storms, and other severe weather conditions. The challenge of living on such a planet would be immense, requiring not only advanced technology, but also an understanding of the unique forces at play. The extreme conditions brought about by the planet's rapid orbit and size highlight the delicate balance required for any form of sustainable life or exploration in these far-off worlds. Additionally, a fast orbit can lead to tidal locking, a phenomenon where one side of a planet is perpetually exposed to its star, while the other side remains in eternal darkness. This creates an extraordinary divide in conditions. The side constantly facing the star becomes scorched by unrelenting heat, while the opposite side plunges into freezing cold. The stark contrast between these extremes produces a volatile twilight zone, the narrow strip of a planet caught between the two environments where chaotic and unpredictable weather patterns thrive. In this region, temperatures fluctuate drastically, and the weather itself becomes a force of nature in its own right. If life were to exist on such a planet, it would need to possess remarkable adaptations to survive these harsh realities. These life forms could be exceptionally resilient to temperature shifts, or they might have developed unique mechanisms to endure brutal radiation. The balance between a planet's size, orbit, and proximity to its star creates a tantalizing array of possibilities, demonstrating just how varied and extreme planetary conditions can be throughout the universe. One such example is the exoplanet HD 80606b. This gas giant orbits its star at a highly eccentric distance, resulting in extreme temperature shifts. During its closest approach to the star, it experiences blistering heat, while the distant part of its orbit cools dramatically. These fluctuations in proximity to its star cause the planet's surface temperature to soar to over 1,000 degrees Celsius at its closest approach, a level of heat that is far beyond what any human could endure. The intense heating triggers powerful winds and storms which ravage the atmosphere. If humans were somehow exposed to the conditions on HD 80606b, they would find themselves in an environment so hostile that life, as we know it, would be utterly unsustainable. The air, composed mostly of hydrogen and helium, would not support respiration. The combined forces of the blistering heat and violent storms, with wind speeds potentially reaching thousands of kilometers per hour, would render survival impossible. Imagine being caught in a tempest so fierce that the atmosphere feels more like a boiling cauldron than anything resembling breathable air. As the planet moves away from its star, temperatures plunge into a frigid, almost unimaginable cold. The sharp transition from scorching heat to freezing cold could cause massive turbulence in the atmosphere, swirling massive clouds in an attempt to balance these drastic changes. The weather on HD 80606b is so volatile that it might resemble hurricanes, but on a scale far grander and more destructive than anything we experience on Earth. If life exists there, it would undoubtedly thrive in ways so alien to us that it defies our understanding of biology. Yet despite the inhospitable conditions, humans are drawn to explore such extreme environments. Studying planets like HD 8060b not only expands our knowledge of planetary science, but also raises profound questions about the limits of life and the potential for resilience in the universe. By understanding such extreme weather patterns, we deepen our appreciation of the delicate stability of our own planet and the immense challenges humanity might one day face in the far-flung future. On Earth, fierce winds and violent storms already pose significant risks. These natural forces have the power to devastate infrastructure, disrupt daily life, and endanger communities. Powerful gusts and torrential rain can trigger floods, landslides, and widespread destruction, often displacing thousands of people. In the aftermath, recovery is a prolonged process, one that can stretch out for months or even years as communities rebuild and adapt to the new reality. Wind patterns, such as those generated by hurricanes and typhoons, can reach astonishing speeds, often exceeding 150 miles per hour, creating chaos wherever they strike. These extreme weather events are stark reminders of nature's unpredictability, forcing humanity to constantly adapt its infrastructure and emergency response strategies. But the threat extends beyond the immediate physical dangers of these storms. The aftermath often leaves entire communities vulnerable to a public health crisis. Infrastructure damage can cripple access to vital resources like electricity, clean water, and communication services, leading to widespread shortages. For many communities, the rebuilding effort takes years, and the economic burden can leave lasting scars. As the global climate continues to change, scientists warn that we can expect an increase in the frequency and intensity of such storms. This only adds another layer of complexity to the challenge of ensuring human survival in the face of ever more extreme weather. Adapting to these changes requires innovation on many fronts, from designing buildings that can withstand powerful winds to creating better emergency preparedness systems. Accepting the reality of extreme weather events and their role in shaping our planet's future is essential if humanity is to thrive in an increasingly volatile world. On the far side of the universe, the exoplanet WASP-31b offers another glimpse into the dangers of extreme planetary conditions. This hot Jupiter, a gas giant that orbits perilously close to its star, experiences a constant barrage of intense heat. The surface temperatures on WASP-31b far exceed the threshold of human survival, creating an inhospitable environment where even the most advanced technology would struggle to offer protection. But it's not just the extreme heat that makes WASP-31b dangerous. The planet's thick atmosphere, primarily composed of hydrogen and helium, creates an impenetrable cloud cover, further reducing visibility and complicating any potential exploration. The sheer density of the atmosphere makes navigation nearly impossible and turns any mission to explore this planet into an almost insurmountable challenge. For any human attempting to survive or explore such an environment, the odds would be overwhelmingly stacked against them. Yet, the planet's existence invites critical questions about the limits of habitable environments and the resilience required to thrive in the most extreme corners of the universe. The exoplanet WASP-31b, situated more than 300 light-years from Earth, presents a series of extreme and hazardous challenges for any potential human explorers. Its hostile environment, composed of a toxic and volatile atmosphere, coupled with unpredictable and violent weather patterns, would pose significant risks to anyone attempting to venture there without the most advanced and comprehensive safety measures. Moreover, the presence of a variety of chemicals in the atmosphere introduces another layer of danger. The very air on WASP-31b could prove toxic to humans, making even basic survival a daunting prospect. This planet is not merely a place of atmospheric intrigue, but a serious reminder of the potential hazards that await beyond our world. WASP-31b is subjected to fierce storm systems, often driven by the extreme heat and rapid wind velocities that characterize gas giants. These storms, with winds that can reach speeds of several hundred kilometers per hour, could create hazardous flying debris, while the intense turbulence could make aerial exploration perilous. No form of exploration, whether from the ground or the air, would be easy. The planet's extreme temperatures, coupled with unpredictable and violent weather, would require explorers to deal with a multitude of challenges just to survive, let alone conduct meaningful exploration. The environmental conditions on WASP-31b serve as a striking reminder of how vast and varied planetary environments can be across the universe. These conditions differ radically from anything found on Earth, and they demand a reevaluation of how we approach interplanetary exploration. As humanity turns its eyes to distant stars and planets, it is crucial to remember that our ability to understand and thrive on these worlds may require new technologies, innovative thinking, and a deep respect for the unknown. In addition to its tempestuous weather, WASP-31b has become a focal point for astronomers and chemists who are eager to understand its unique atmospheric composition. This gas giant, significantly larger than Jupiter, is challenging our current understanding of planetary formation and atmospheric behavior. Scientists are increasingly concerned about the chemical signatures detected in the atmosphere, which seem to defy expectations and suggest that our models of planetary chemistry may be flawed or incomplete. When researchers analyze the gases and compounds that make up the atmosphere of WASP-31b, they often encounter unexpected elements that could have profound implications for our understanding of planetary systems. The discovery of such anomalies raises alarms because they suggest that the existing scientific models used to predict the behavior of distant planets and their atmospheres might not be as accurate as we once believed. These new findings spark a cascade of questions about the nature of habitable environments and the potential for life beyond Earth. The extreme temperatures and pressures on WASP-31b help sustain a volatile atmosphere filled with exotic and sometimes hazardous compounds. If the current models fail to accurately predict how these chemicals behave under such extreme conditions, it could hinder the search for other exoplanets that might be capable of supporting life. This uncertainty highlights a fundamental challenge in the search for life beyond Earth. As we uncover more about distant worlds, the answers to critical questions may only become more elusive. The more we learn, the less we seem to understand, and this paradox underscores the complexities of studying the universe. This scenario calls for a rethinking of long-standing assumptions about planetary systems. Scientists must remain open to revising their theories, as new data continues to challenge the foundations of current research. Furthermore, collaboration between different fields of study, chemistry, physics, astronomy, and biology, will be essential in building a more holistic understanding of these distant and alien environments. The search for answers to the most profound questions about life in the cosmos may require an ongoing shift in perspective. As researchers continue to study planets like WASP-31b, the lessons learned from these extreme environments could help shape our understanding of the universe in ways we have yet to fully grasp. Each discovery reveals just how much we still have to learn and how much more complicated the task of exploring distant worlds can be. Another fascinating exoplanet, WASP-885714b, offers an entirely different yet equally inhospitable environment. Situated on the extreme edge of known planetary systems, this icy world presents a chilling portrait of a frozen realm where temperatures plummet to levels that would be unbearable for any known life form. The surface temperature of WASP-85714b is estimated to be around -270 degrees Celsius, cold enough to turn the planet into a world of perpetual frost and frozen gases. The frigid environment on WASP 85714b reshapes the planet's atmosphere into a series of thick clouds composed of frozen compounds. These clouds serve to conceal the surface, creating an opaque and dense veil that obscures any attempt at visibility. The atmospheric conditions are harsh, and any visitors to this icy world would not only encounter a suffocating cold, but also bone-chilling winds that sweep across a barren, desolate landscape. The haunting silence of the planet would only add to the feeling of isolation, as the extreme cold prevents any water from existing in liquid form, solidifying instantly upon contact with the atmosphere. The kind of cold on WASP 85714b is not the kind that simply numbs the skin. It's the kind of cold that can freeze solid any exposed matter, from water to metals to gases, instantly solidifying whatever it touches. Any exploration or scientific inquiry here would have to overcome the challenges posed not just by the temperature, but by the very nature of the planet's atmosphere, which seems to be an impenetrable barrier to traditional forms of exploration. In this frozen alien world, the very concept of life as we know it seems impossible. The frigid conditions render it a realm where even the most basic biological processes would grind to a halt, making it an inhospitable environment for anything resembling life on Earth. The haunting aspect of this world, however, lies in the mystery of what, if anything, could survive in such extreme cold. As we probe deeper into the cosmos, these ice worlds offer stark reminders of how diverse the universe is and how challenging it will be to uncover the true nature of life in all its forms, wherever it may exist. The extreme cold conditions of this distant world shape its inhospitable atmosphere, adding an unnerving layer of danger. As the air chills to bone-cracking temperatures, frost and ice crystals paint a surreal, almost mystical landscape. Yet, beneath this beauty lies a stark reminder of desolation. The absence of warmth signals a life-sustaining force that this world simply cannot offer. It's a place that evokes foreboding, a world where survival itself becomes the greatest challenge. The threat of frost, compounded by an unforgiving atmosphere, casts a shadow over any adventurer brave enough to consider such a perilous journey. Survival in such an environment becomes an urgent matter. The lack of thermal energy places an insurmountable obstacle before even the most sophisticated technologies. These advancements, powerful in less extreme conditions, would quickly falter when faced with the planet's icy grip. The relentless cold, thick clouds that obscure the sky and the haunting, pervasive silence of the world form an atmosphere that could unsettle even the bravest. The combination of these elements creates a chilling sense of isolation and danger. A world so alien that it triggers the imagination, conjuring visions of barren, lifeless landscapes. For those fascinated by the cosmos, this extreme cold is more than just a meteorological anomaly. It's a reminder of the universe's vast and unpredictable extremes, forces beyond our comprehension and control. The absence of sunlight on this world only amplifies the challenges that would face any human endeavor. Without the warmth of the sun, basic survival becomes a near impossible feat. The impacts ripple across everything from agriculture to energy production, all of which depend heavily on the life-giving rays of our star. In the absence of sunlight, photosynthesis, the process through which plants convert light into energy, is stifled. Without it, crops would fail. A world without sunlight would spell disaster for food production, leading to food shortages that threaten the very foundations of global food security. Our agricultural systems, deeply reliant on sunlight, would collapse, sending shockwaves through economies, especially those that rely heavily on farming. The consequences would be severe, not only for local economies, but on a global scale, as hunger and instability would rise. Energy production would also grind to a halt. In an era where renewable energy sources like solar power are becoming indispensable in our fight against climate change, a world devoid of sunlight would rob us of this vital resource. Societies would be forced to fall back on fossil fuels, the burning of which only exacerbates environmental destruction. This shift would deepen the global energy crisis, forcing communities into further dependency on non-renewable resources and driving up energy costs. The ripple effect would strain households and businesses alike, creating a vicious cycle of environmental degradation and economic hardship. Yet the effects of prolonged darkness reach beyond just the physical world. Sunlight is essential to human health, regulating our circadian rhythms and influencing hormone levels. Its absence would disrupt sleep patterns and contribute to a surge in mental health issues, from anxiety to depression. Without sunlight, outdoor activities become increasingly difficult, depriving people of much-needed exercise and social interaction. In a world without the sun, the emotional toll would be as severe as the physical. The cultural implications are equally profound. Throughout history, humans have revered the sun, recognizing it as a source of life, vitality, and inspiration. Festivals and rituals dedicated to the sun have been integral parts of cultures around the globe, celebrating the light that sustains us. In a world locked in perpetual darkness, these celebrations would fade into memory, lost in the shadows of a new reality. Humanity would need to adapt, seeking new ways to find meaning, reinventing traditions, and creating fresh connections to the world around them. The absence of sunlight would force a deep reflection on our relationship with energy, health, and the environment. This change would not only alter the way we live, but challenge the very essence of what it means to be human. How would we adapt to such a stark alien world? How would we sustain ourselves both physically and emotionally? These questions would drive humanity to reimagine its existence in ways previously unimaginable. Teegarden Star B, an exoplanet located around 12.5 light-years from Earth, has captured the attention of scientists and astronomers. Its proximity to our solar system and potential for habitability make it an intriguing subject of study. However, the prospect of human exploration reveals daunting challenges, particularly the scarcity of resources. The planet's atmosphere remains poorly understood, and it is suspected that Teegarden Star B has neither a breathable atmosphere nor sufficient water resources. This raises critical questions about the viability of sustaining human life on this distant world. Water, essential not only for drinking but for agriculture and life support systems, is a crucial resource for any human expedition. Without it, long-term habitation would be virtually impossible. The lack of natural resources forces explorers to consider alternatives, new, innovative technologies to generate food, water, and oxygen in a hostile environment. Yet these solutions come at a steep cost and would demand unprecedented levels of ingenuity and resilience. The challenges of exploring and potentially settling on Teegarden Star B are immense. From the fundamental necessity of water to the daunting cold and darkness, this planet presents a picture of extreme isolation. The stark, inhospitable conditions leave no room for error. Yet, for those driven by the thirst for discovery, Teegarden Star B represents a final frontier, a place where survival would demand everything humanity has to offer. Exploring distant planets, especially those with no resources to support human life, presents one of the most daunting challenges humanity has ever faced. Astronauts venturing into these unknown realms would find themselves entirely dependent on supplies sent from Earth. This means every aspect of their survival, from food to breathable air, must be carefully planned, prepared, and transported, often in enormous quantities. The logistics of such missions would not only increase their cost, but also complicate every step of the journey. The dream of colonizing other worlds would shift from an ideal of sustainable settlement to a prolonged, perilous expedition, requiring meticulous calculations and unyielding resilience. Beyond the physical survival challenges, astronauts would also have to contend with immense emotional and psychological stress. The isolation, far from the comforting embrace of Earth, and the lack of any local resources could severely affect mental well-being. The silence of deep space, combined with the uncertainty of their environment, would place significant strain on even the most mentally prepared individuals. Any mission to a distant star, like the one orbiting Teegarden B, would need not only physical readiness but also advanced psychological support systems to help the crew remain focused, resilient, and mentally healthy in the face of such overwhelming adversity. As humanity ventures into these unexplored territories, the exploration of distant worlds transcends scientific inquiry. It becomes a testament to the limits of human endurance, creativity, and ingenuity. Every step on alien soil is both an achievement and a confrontation with the unknown. This exploration often brings with it a profound and eerie silence, Scientists, so accustomed to the symphony of sounds on Earth, are greeted by an unsettling quiet. On planets or moons without atmospheres, sound cannot travel, turning these foreign landscapes into eerily silent worlds. For astronauts, this absence of noise serves as a stark reminder of their isolation in the void of space. On Earth, we are constantly surrounded by the hum of life. The rustle of leaves, the distant cry of animals, the rush of wind, all of these are sounds that tether us to the world we know. But on barren planets like the Moon or Mars, everything is different. The air is still, the ground unmoving. There are no animals, no wind, no rustling leaves to break the silence. Instead, the only sound is that of one's own breath and thoughts, which can quickly grow louder in the stillness. This unrelenting quiet can force an astronaut to confront a strange and unsettling reality. They are alone, surrounded only by an unbroken emptiness. Such environments can provoke a deeper sense of vulnerability. In the vastness of space, where there is no external sound to reassure the explorers, the mind often begins to wander. The absence of familiar noises can heighten one's awareness of surroundings, intensifying feelings of insignificance when confronted with the endless expanse of the cosmos. For many, the silence stirs a deep, existential unease. What dangers might lie hidden in the vast unknown? The mind races with these thoughts, and the silence itself becomes a canvas for fears, uncertainties, and countless what-ifs. This profound quietness, however, is not merely a physical absence of sound. It carries with it a psychological weight. It challenges the very essence of human existence: communication, connection, and survival. To stand on a barren world, facing a silent, unfeeling cosmos, is to reckon with one's place in the universe. Each small movement, every careful decision, becomes a reminder of just how fragile human life is. And yet, despite this isolation, the exploration continues. The silence serves not only to challenge, but to inspire. Each step on an alien surface, each whispered hypothesis, each cautious advance into the unknown pushes humanity forward, even as it forces explorers to confront their deepest fears and insecurities. Upsilon Andromeda D, an exoplanet in a distant star system, embodies many of these challenges in an even more extreme form. This world is situated within a binary star system, meaning it is subject to the complex gravitational interplay between two stars, rather than the predictable cycles we experience in our own solar system. This unusual dynamic causes extreme fluctuations in temperature, as the planet might experience intense heat from its dual stellar sources, only to be plunged into long, freezing periods of darkness. In addition to this chaotic temperature cycle, Upsilon Andromeda D's atmosphere is thick with hydrogen and helium, creating an environment of high pressure that would be lethal to humans without advanced life support systems. This thick atmosphere could also contribute to violent weather patterns, with storms raging unpredictably, and the planet being constantly bombarded by intense radiation from its nearby stars. Such hostile conditions would make exploration extremely hazardous, requiring the highest levels of preparation and technology to even approach the surface. The planet's gravity presents another issue. Depending on the mass and size of Upsilon Andromeda D, its gravitational pull could differ drastically from what we experience on Earth. If it is stronger, astronauts may find their bodies strained by the extra weight. If weaker, they may experience the opposite challenge, struggling with muscle loss and bone degeneration over time. The constant adjustment to such gravitational shifts would not only be physically taxing, but also difficult to overcome in the long term. Perhaps one of the most concerning factors, however, is radiation. Without a protective magnetic field or thick atmosphere, Upsilon Andromeda D is likely to be a haven for deadly cosmic radiation. Astronauts would face a much higher risk of developing cancer or other severe health problems. Every moment spent on this world would bring them closer to a potential exposure to these deadly particles, making the need for reliable radiation shielding more critical than ever before. Taken together, these various factors illustrate the hostile and unpredictable nature of the universe beyond our own planet. Each celestial body offers its own unique set of challenges and dangers, reminding us how fragile our existence is in the grand scheme of things. These extreme conditions highlight not only the immense physical demands of space exploration, but also the psychological toll it can take on those brave enough to face them. The vastness of space is a constant, looming presence for any astronaut exploring distant worlds. For those visiting planets like Mars, the sense of isolation is palpable. The feeling of being surrounded by an endless void, with Earth millions of kilometers away, can trigger an overwhelming sense of existential dread. The distance, the unpredictability, and the inherent danger of space travel combine to create a psychological burden that weighs heavily on explorers. This overwhelming awareness of just how small and fragile humanity is in the face of the cosmos can spark deep feelings of fear and anxiety. Yet, despite these immense challenges, humanity continues to press forward. The desire to explore, to understand the universe, and to answer the questions that have driven us for centuries is stronger than the fear that arises from isolation or danger. Each mission to the stars, no matter how daunting, is a step toward a deeper understanding of ourselves and the universe around us. And in the silence, the vastness, and the uncertainty, we find not just fear, but hope, resilience, and the indomitable human spirit. The environment of distant planets presents numerous challenges that are both physically and psychologically daunting. The barren, stark landscapes, often devoid of life, amplify feelings of loneliness and isolation. For astronauts stepping onto these alien worlds, the vast expanses of red dust stretching endlessly before them serve as a constant reminder that they are far from home, surrounded by the unknown. This overwhelming desolation, far from being merely a backdrop, intensifies the emotional state of those on the mission, heightening their awareness of their own fragility in the face of an unforgiving universe. The psychological strain of being so far from Earth is not just about the isolation from loved ones, but is exacerbated by the extreme conditions of space travel itself. Living for extended periods in tight, confined spaces, whether aboard a spacecraft or in a planetary habitat, necessitates intense teamwork and collaboration. Yet this intimacy can be a double-edged sword, as the stresses of isolation and mission pressures can escalate into interpersonal conflicts. The astronauts, bound together by necessity, must manage not only their emotions, but also the fragile dynamics of their relationships, all while maintaining a sense of camaraderie in an environment where immediate assistance from Earth is a luxury they may not have. Astrophysicists and psychologists agree that the psychological challenges of space exploration are not merely individual struggles. They are deeply embedded in the broader human experience of venturing into the unknown. The exploration of distant planets, such as the enigmatic exoplanet Rho Uchi b, is as much a psychological journey as it is a physical one. Recognizing this complexity is vital in preparing astronauts for the mental and emotional toll these missions can exact. Without such understanding, ensuring the well-being of astronauts as they navigate the vast and uncharted realms of space would be impossible. Rho Uchi b, a captivating exoplanet located approximately 40 light-years from Earth, presents its own unique set of challenges. Orbiting a binary star system, it is subjected to gravitational forces and radiation levels unlike anything we experience in our own solar system. For explorers contemplating missions to distant planets, such as Rho Uchi b, the threat of the unknown looms large. The uncertainty of facing hazards like intense radiation or the unpredictable impacts of space debris heightens these fears, making the idea of such exploration seem both exhilarating and terrifying. The exploration of these distant worlds is fraught with numerous unknowns. While scientists have mapped countless celestial bodies and their orbits, much of the universe remains a mystery. The region of space in which Rho Uchi b resides is still poorly understood, and the dynamics of its surrounding systems are incomplete. This lack of knowledge brings with it a deep sense of anxiety, as the risks associated with traveling to such remote locations become difficult to predict or quantify. For missions targeting Rho Uchi b, scientists must not only account for the planet's physical terrain, but also consider factors like atmospheric conditions, temperature fluctuations, and the potential for catastrophic events that could emerge at any moment. But perhaps the most profound and unsettling element of these missions is the inherent fear of the unknown. Space exploration has a long history of surprises. For every successful mission, there are countless tales of unexpected equipment failures, environmental conditions that were not anticipated, and tragically, the loss of life. The possibility that Ryuchi B might harbor invisible dangers, whether in the form of toxic gases, extreme weather conditions, or hostile environments, adds a layer of complexity to these missions. And as if that weren't enough, the isolation and confinement astronauts experience in space amplify these fears, making the already daunting task of exploring uncharted worlds feel even more perilous. These challenges, spanning the intimidating distances of deep space, the unpredictable environments of distant planets, and the psychological strain of isolation, combine to create a unique and often anxiety-laden experience for those tasked with exploring such realms. For all the wonder and excitement that drives explorers, the fear of the unseen and unknown is a very real and pressing concern in the field of cosmic exploration. The tension between the allure of discovery and the ever-present threat of danger is a delicate balance that every astronaut must navigate, one that defines the human spirit's relationship with the vast, uncharted cosmos. Navigating the myriad star systems surrounding Ryuchi B is another daunting challenge for human explorers. As part of a complex stellar network, Ryuchi B exists within a dense field of celestial bodies, each with its own gravitational pull. The gravitational forces at play create intricate and unpredictable fields that make navigation a constant struggle. As astronauts approach these celestial bodies, they must continually adjust their trajectories to avoid being pulled off course. Every maneuver, no matter how small, carries high stakes. The varying distances between these star systems add another layer of complexity to the journey. Some stars are light years apart, while others appear much closer due to the irregular nature of spatial configurations. This requires incredibly precise calculations and real-time adjustments. Astronauts would need to rely on advanced navigation systems and artificial intelligence to keep track of their position, speed, and trajectory in order to avoid catastrophic collisions with surrounding celestial objects. Adding to the difficulty of these challenges are the communication delays that are inevitable across such vast interstellar distances. Even with the most advanced technology, signals take time to travel from Earth to spacecraft and back. This means that by the time a crew receives updated coordinates or navigational guidance, they may already have drifted significantly off course. What might seem like a minor deviation could, with time, lead to dangerous errors, forcing astronauts to rely more heavily on their instincts and problem-solving abilities. The psychological strain this induces can be immense, as the crew must continuously make high-stakes decisions based on information that could already be outdated. This sense of profound uncertainty weighs heavily on the crew, testing their ability to work together under pressure. Every successful navigation through a star system might be seen as a small victory, but the constant threat of a critical error looms large. The mental toll of this uncertainty, combined with the isolation and confined living conditions, makes the already complex task of exploring distant worlds even more daunting. Each challenge presents a reminder of both the brilliance of human innovation and the vulnerability of our existence in the vast expanse of the universe. As humanity continues its quest to explore the unknown, it becomes clear that the challenges of space exploration are not just technical, they are deeply psychological, deeply human. The future of cosmic exploration depends not only on our ability to solve the scientific and technological problems we face, but also on our capacity to confront the emotional and mental challenges that come with venturing into the great unknown. Thanks for watching.